Hello? All right. All right, cool. So this is PromCon EU 2023, day 1. Welcome, everyone. So before we get started, a couple of organizational things, but before we even talk about that, quick show of hands. Whose first PromCon is this?
Yo,
wow.
Nice.
Very, very cool. Welcome, everyone. Whose second PromCon is this? Okay, okay. Whose third PromCon is this? Okay, getting lower. Whose fourth PromCon is this? Whose fifth? How many have we had, actually?
Do we count the one
I think
this
now
were
we're down
online?
to who has been to every single one, including the 16 one.
Nope.
And I think I'm only going to see one hand go, or two hands go up. Who was also at the unofficial first PromCon, where there were like 4 people? Yeah, I see 2 hands, exactly.
Two of the 4 people are here.
All right, so we are here at the wonderful Radialsystem. For both PromCon and Prometheus, this is kind of a homecoming. For those who didn't know, Prometheus was originally created here in Berlin, and the first PromCon was also in Berlin. And then for several years, we were in Munich, organized by Richie. And so now we, as Polar Signals, volunteered to run this year's PromCon. So, most important thing, of course, for everyone, the Wi-Fi. We'll also put this up in between so that if you don't catch it, but we'll take a moment so that everybody can quickly scan the QR code.
All the phones are up.
Yeah, I can still see phones up. Okay, okay. Okay, I think we're good. Quick hands for our sponsors, Diamond sponsors, Grafana Labs and Cloud Native Computing Foundation. Quick hands. This event quite literally wouldn't be possible without our sponsors, so also hands for Red Hat, Ollie, and, well, not for us, but... All right, last thing from my side, we follow the CNCF Code of Conduct, TLDR. Please be nice to each other, please be excellent to each other, and we'll have a wonderful event. And with that, I'll hand off to Matthias.
Yeah, so everybody should have a shirt by now. If you don't have one or it's the wrong size, come to the registration and we find one that's fitting for you. In the boxes beneath, there's more. We just didn't want to like throw them all on the table. However, they are first come, first serve, so if they are gone, they're gone. Stickers, we have stickers, Prometheus stickers. There's going to be sponsored stickers by Grafana, Polar Signals, probably Red Hat, and Ollie and everybody has stickers. We kindly ask you to not put them into the venue, like on the bathrooms or whatever. Like we are going to need to clean them up, so if you put them anywhere, it's our responsibility. But yeah, you can take them and you can put your stickers on the table later on, and then obviously put them on laptops and stuff, right? We have lots and lots of great talks lined up. Really, really looking forward to those. We always have 25 minutes of talks, roughly, and then 5 minutes of Q&A, and we really kindly ask you to ask questions and not put statements up in the Q&A. If you are putting up statements, we will shut you down rather quickly. So yeah, ask questions and don't put statements up. And for all the speakers, you can go right there, left side of the stage, and get wired up with a microphone roughly 10 minutes before your talk. Lightning talks. So we have, I think, lined up for today, roughly 6 lightning talks. They are at most 5 minutes, and we still have slots. So yeah, 6 lightning talks, each 5 minutes is roughly half an hour. So yeah, if you want to, you can still sign up for lightning talks. And we also have lightning talks tomorrow. So if you have your like cool side project or you want to talk about anything in 5 minutes, you can go to the registration booth, and we have pen and paper, old school, and you can write it down still and get into the line for lightning talks for the next 2 days, which will be quite fun usually. Hi, Mom. We are live on the live stream. We can send it to our friends and colleagues who can't be here, and they can watch the live stream during the event. And after the event, we get recordings of everything. We'll cut it and publish it to the Prometheus YouTube channel later on. So that is something that you can look forward to in the next 2 weeks, depending on how much work and time and effort it will be. Mastodon and Twitter, you can find Prometheus on both. Either one works, whatever you prefer. And if you tweet anything or toot anything about PromCon, please use the hashtag PromCon. Yes. If you see anyone with a badge that has like an orange name that's Prometheus team, I don't know if this is going to help anyone, but that's kind of a speciality. If you want to talk to someone, maybe they can forward a question to us. In most cases, they know how to find us. But if you have questions, also the registration booth is probably a good spot to look for answers. Ja.
All right, then let me tell you a bit about the food and drink. So we don't have breakfast, unfortunately, but we will have something for you at the first break, which is bread and mini bagel. But for lunch, we will have pasta, salad, vegan curry, and also dessert, of course. And later in the afternoon, we will have a bagel with pastrami and some apple pie. Later in the evening, at the social event, we will have tacos and rice bowl, dessert, and of course, drinks. For tomorrow, we will have, we'll have the coffee and tea in the morning again, and then the first break we'll have salmon, tramezzini, sorry if I pronounce it wrong, and some cookies. For lunch, we'll have duck breast, and ragu, and some salads. And of course, Königsberger Klöpse, which is meatballs, yeah. I'm told. Yes, and later in the afternoon, we have bagels and cakes. So for social event tonight, it starts at 6 until 10 p.m. at Budget. It's a beer garden. And you will get your wristband there because we reserve like half of the for us. You need to go to the bathroom in the other side, so you can only get in again with the wristband. Don't lose it because I don't have it. They only gave it. Yeah. And how to get there? We can walk like 30 minutes from here, and it's also a nice walk down the street along the East Side Gallery, and then you cross the bridge, the Oberbaum Bridge, for those who won't have time to do the sightseeing in Berlin. So you get to see 2 best of the East Side, at least. Yes, or if you don't want to walk, you can take the bus on the other side of the river, either 165 or 265. Or, of course, you can take Bolt or taxi. Yeah, that's it that I have to tell you. Oh, I forgot that food and drink will be served in the hall next door. And then you can also take it outside to enjoy at the river or something. Cool. Then I hope you all have a wonderful time. And that being said, let's start.
Yeah, I mean, if there are any questions, we can briefly... you can shout them, I will repeat them, but okay, no questions right away. Yeah, feel free to always reach us, and we're happy to answer them.
Exactly.
All right, then let's start.
Let's put up the Wi-Fi until the next talk.
But I'm doing the next time, so I need to change. Oh, spoilers. No. I guess we can start early.
Yes.
Have more time for Q&A. All right. please welcome to the stage with me Julian. He is a longtime Prometheus maintainer, and we're going to talk you through Prometheus and its ecosystems and what has happened in the last year since last PromCon in Munich in 2022. So quick show of hands. We already did a quick show of hands. Who has been here for the first time or second time at a PromCon? But who has just recently started using Prometheus? Like for whom is it like quite new as a thing to use? Okay, couple of hands, but we'll talk about what is Prometheus regardless. So those who know it very well, you can correct me later, but otherwise we'll talk about what Prometheus is. So it is a metrics-based monitoring and alerting stack. You can use it for instrumentation and application for system monitoring as well. It collects metrics and stores them, and after storing it, it makes it queryable efficiently, and you can use all of that to alert on certain things in your system that you don't want to occur. And obviously, we all love dashboards and looking at dashboards, so you can put those queries into dashboards and make your metrics look really nice. It is for all levels of the stack, so whether you're running on bare metal or something like Kubernetes or serverless, whatever, it just uses HTTP for the most part, so it basically runs everywhere these days. Quick history, as Frederick mentioned in the intro, it started at SoundCloud. You can ask Julius if you want any more details. He's around, by Julius and Matt Proud. They started it after coming to SoundCloud and wanting something like Prometheus, but nothing really existed back in 2012. So they started working on it, and it was fully open source in 2015. And then in 2016, the CNCF was brand new, and Prometheus was one of the very first projects who got adopted into the CNCF, and then also was released as a first version back in 2016. Pretty exciting times. I vividly remember this. And then in 2017, shortly after Prometheus 2.0, with a full rewrite of the storage happened, and that's kind of the foundation of what Prometheus still uses, and the TSDB is since then what we're using in the way it works, like cutting blocks every 2 hours and stuff. That was introduced back then. And in 2018, I think right after Kubernetes, Prometheus graduated as the first, as the second project in the CNCF. Last year, we had a really cool documentary going live. Probably lots of people have seen it, but in case you haven't seen it, this is kind of a, I think, 20-minute nice documentary, different users describing what Prometheus has done for them, how it helped them, and kind of a bit of a backstory there as well. Latest numbers, right? You might see something at the top right hand. Prometheus has reached 50,000 stars on GitHub, so that's something to celebrate, even though stars are just stars, but that's pretty cool. Even more exciting, though, is that the contributor list is ever growing, so even in the last couple of months since updating the slide, we had like another almost 30 new contributors, which is even more exciting to me. So there's a vast ecosystem around people who want to contribute, who want to make the project better, and we definitely invite you all to do so and to contribute, to talk, and we'll have more on meetings, etc. you can join, so that is super nice to see that still, after so many years, people are investing and contributing to Prometheus. Which brings us to expanding the team. So Julian invited Josh to join the Prometheus team. He's going to talk about the new alert manager UI, for example. Then we had Brian Borham, who has contributed significantly in the past and since joining Prometheus team, who joined. I had Kemal joined the team. He has helped a bunch with the client Golang, and then more people are joining, and both of them were longtime maintainers of the client Ruby. So it's super nice to onboard those people and integrate them into the team and have them part of the larger community, but also recognize their efforts and contributions of the past. And yes, Jesus, you're somewhere in the audience back there. He's also he joined Prometheus team and going to talk about some super nice updates that are coming in the next months. So what is Prometheus? As I said, it's like for monitoring all sorts of systems. So whether you have a web app or like a API server like Kubernetes, we usually instrument those with a client library, as mentioned, client Golang or client Ruby, client Java maybe. There's also going to be a good talk on that. And then we can have different types of programs that might not even need to be modified to export metrics. So we have usually these Prometheus exporters that run along those programs, and then they can expose metrics as well. And by exposing metrics, we mean that they have an HTTP endpoint that Prometheus can then find and scrape and ingest the data into the time series database over time. And Prometheus actually can discover those endpoints, those targets to scrape using service discovery. So yeah, DNS or Kubernetes are super popular ones to find those endpoints that need some scraping. So you don't need to like manually type IP addresses or anything like that. But Prometheus can dynamically do that in these like dynamic cloud environments these days. And then once you have the data in Prometheus, you can obviously use something like Grafana or just the Prometheus web UI, maybe something like PromLens to query it, or just use some automation to get something out of the database again. And if you're sleeping at 3 a.m., you might not be looking at dashboards the entire time. We have alerting, so you can have alerts being sent based on queries that you can write, and those are sent to Alert Manager for deduplication and routing to different notification systems. Slack, Discord was recently added, so many others. So what is a time series, right? We identify a time series by this identifier. We'll briefly talk about this in just a second on the next slide. And then this identifier always has in64 timestamps, and then always a float 64 value. So that's kind of the key value pairs, always a timestamp and a value. And we identify these time series by the metric name, which is kind of a special label. It's actually just a label under the hood as well, but we have a metric name, and then we have these labels that are used to identify some more specific metrics by doing that. And it's really good because it's super flexible, and you don't have a hierarchy, so you can slice and dice the data as you need it to be for your queries. And PromQL is the query language. It's a functional query language, and it's especially great for time series computation. It's not a SQL-style query language, and that's also quite of a deliberate choice. Otherwise, the queries can get really, really long if you do all of the label matchers and selectors in the queries. So that's why PromQL exists. You can answer questions like, get me my entire infrastructure with more than 100 gigabytes of capacity of drives, and those shouldn't be mounted on the root. So that's like the mount point is not / right? And then we can query for those as well and get some very specific answers that we're looking for. The alerting, we kind of embed those queries into the expression field in a YAML file. So that's what's been highlighted here. And we can do something like alert us if the error rate is above 5% for more than 5 minutes. And we want to have a severity critical. So based on the severity label, we can either route to like a Slack if it's maybe warning, or like a PagerDuty or some other on-call system if we want to actually page people and wake them up possibly in the night. So that's what we use these for. And then bridging the gap, not everything I already mentioned in one of the first slides is Prometheus native or exposes metrics by default, even though I think the ecosystem has really grown in the last 6, 7, 10 years, I guess. one could say. So many applications these days are starting to just expose a metrics endpoint, which is incredible to see, but if it doesn't exist, you can still use these exporters, small programs that would query the application's API, do some transforming, and then expose the data as a Prometheus exposition format, so Prometheus can scrape it. And with that, I want to hand over to Julian, who is going to talk about what's new in Prometheus.
Yes, so let's look at what is new in Prometheus. First, we look at Prometheus, and then a bit wider in the Prometheus and Prometheus Echo community GitHub organization. So native histograms, which were introduced at the last PromCon, what is an histogram? It enables you to measure distributions. And this is an example of the distribution of response time. And you can see the histograms that were used in Prometheus before on the left side. And on the right side, you have the new histograms. And what we can see is that the new histograms basically enables you to really tell more the story, because this is the same data you are seeing with both the old and the new histograms. And what is important with the new native histograms is that they are much more efficient and you get a lot more granularity. What has been happening in the last releases of Prometheus, but also in the client libraries, is that we are really integrating them into every piece of Prometheus. So there has been a lot of improvement regarding the performance, regarding PromQL, but now they are also in more client libraries, so you can really start using them, and we are seeing more and more people using them and contributing to them. So it's really nice to see that the work that the team was doing 1 year ago is still very strong, and we still have many contributions and many bug fixes of those new native histograms. So I encourage you to give it a shot, to look at the talks from last year and to really start playing with the native histograms if you are measuring latencies and alerting on them, because it's really like something that's very, very exciting for the community to just be able to measure correctly the latencies of your applications. So this is the talk that we had at the last PromCon. Yeah, so this is also what you can do when you have so much granularity in native histograms, and yeah. The other improvement that we have included now by default in Prometheus is the string labels build. So what it means basically is that we are now storing the strings differently in Prometheus itself, the labels differently in Prometheus itself. So this is the technical details, but the general idea is that we are able to cut the memory by a lot on certain workloads just by storing the labels differently internally. There is still more work in progress regarding memory reduction of Prometheus, but we are happy to bring that by default to every user. And I think it's really nice improvements to see that we can still push the boundaries of the performance of Prometheus itself. And I really want to thank Brian Boham, because this is mainly his work, and it's really impressive to see the ideas he's coming with and how they are implemented and the effect they have on actual production workloads. Keep firing for, this is a new field for your alerts. So sometimes you have an alert that will fire for like 5 minutes, then the condition will go away and the alert will need to start again. For such use cases, now we have a keep firing for, which means that if the alert is not firing anymore, you can still keep it firing in case the underlying condition comes back. So we have got some customers that had some flapping alerts, and this is kind of helping them with just being able to see, okay, let's reduce the noise, let's reduce the new notifications. You cannot always fix the source of your data. You don't always want to mess with too much complex PromQL queries, because you can try to achieve that in PromQL, but now we have a first-class field for that, so this is also a nice addition. There is also the issue with people that have configuration files with thousands and thousands of reliability configurations or targets or script configs. So We have added the ability now in 2.43 that you can now split your main configuration file and include scrape configurations from different files. So if you want to make your Prometheus configuration more readable, or if you want to delegate a job to a certain team, you can just include config files from different files. So this is also a nice addition for people who like to just split their configuration and work in a Debian style config.d way. In Prometheus 2.47, we are also introducing an OpenTelemetry receiver, which is very, very experimental. It's working, but what we are seeing is that we need to continue working with the OpenTelemetry community and to the client side, and we also need to figure out some stuff on the Prometheus side, but this is a really nice first step directly in Prometheus for supporting OpenTelemetry natively, so that whatever your workload is, or if you are stuck with an OpenTelemetry client, that you can still use Prometheus directly without needing other things in the middle. So this is still very early, but it's a really nice first step, and we have really people involved in that work, both in Prometheus and in OpenTelemetry, to make this work and to find the good answers to bring that to reality and to achieve actually a good compatibility between the two projects. Now, if we go outside of Prometheus itself, and we look at the SNMP exporter, which is used to monitor network switches, which is a quite popular exporter in the community. The SNMP exporter, we have broken the configuration format in the last release, in the 0.23 release, because it was really difficult when you had a networking team that has many different passwords, or when you need to rotate your password, you need to do a bunch of different generators to get your configuration in one place. Now we are splitting that. So now if you have many switches, you can actually split the authentication and the scraping configuration, so the MIP in different files, which makes it a lot easier for people who are managing SNMP exporters. So this is a change that has been very long in the making, but it's a really welcome addition, and it's really a nice improvement for any network administrator which is working with Prometheus. The other improvement in the SNMP exporter is that you can now also query multiple modules in one scrape. So if you have a vendor-specific MIP, so you need to query like, I don't know, Cisco-specific metrics, and you also have a quite more generic MIP with like the basic network speeds, then you can actually combine both of them in the same scrape, and the SNMP exporter will just query the two modules in one scrape. So which is really a nice improvement as well, because you don't need to have multiple jobs if you want to achieve that. So in the past, you needed to have multiple jobs or multiple targets to do that. Now you can just do that all in once. Which brings us also to the MySQL exporter. So the MySQL exporter now supports multiple targets. So previously with the MySQL exporter, if you have two different MySQL servers, you needed to have two different MySQL exporter because we linked one-to-one. Now you can have a configuration file that says, okay, this is my MySQL servers, and when you are querying the MySQL exporter with Prometheus, you can say, okay, I want to query that database or that database or that database. So you can now really use less MySQL exporters than before, which is really nice when you have like three MySQL servers and you don't want to have like the overhead of managing a one-to-one relationship between the exporter and the database. The Java client, so there is a talk about this tomorrow, but I wanted to still say it on stage today. Has reached 1.0 yesterday, and among the exciting new things, we have OpenTelemetry metric support. So if you want to use the lightweight Java client from Prometheus, but you are using OpenTelemetry, you can now emit OpenTelemetry metrics from the Java client, and it is also integrating with OpenTelemetry tracing. So if you are using OpenTelemetry for tracing and Prometheus for scraping, then you can still have like exemplars directly attached to your metrics. The other thing is that the Java client also has native histograms, which is also really cool to see that they are also going to another language than Golang, especially the Java client, which is quite popular. So it's really nice to see that the native histograms will also get more speed and more usage thanks to new programming languages being included. The Alert Manager, we have new receivers for the Alert Manager, so we bring the alerts closer to you if you are using Microsoft Teams, Discord, or WebEx. So you don't need to have an external sidecar if you need to do that, because now we have first-class integration for those new receivers. And then when we mentioned the new team members, we did not mention yet the two last team members, which are the Windows Exporter maintainers, which are joining the team, because we are bringing the Windows Exporter to become an official exporter. So the Windows Exporter was known as the WMI Exporter, then was moved to the Prometheus community, but now it's time to make it really an official exporter and to have it more widespread along the Prometheus community. So by becoming an official exporter, it will move to the Prometheus organization, and you will be able to find and download it directly on the Prometheus website. We had some delay because the license is not Apache 2 but MIT, but now we have fixed that with the CNCF. We got an exception, so it's really the final stage, and we will do the move quite soon. And it's really nice to see new project coming in the Prometheus organization and recognizing the awesome work that has been done in the Windows exporter community, because it's really like an active project, and it's really nice to see that we are actually bringing those people inside this Prometheus team that can bring us also a different perspective on the project.
All right, thank you, Julian. Super exciting stuff, and we'll see lots and lots of these things also being shown at PromCon, so looking forward to that. Bug Scrub is back, so couple of maintainers are meeting every Tuesday, and they're going to discuss contributions, pull requests. So if you have a pull request or an issue or anything that you want to get a more of a one-on-one or at least a face-to-face situation on, you can join those bug scrubs and talk to the team via these online meetings. And then the other one is the Prometheus and ecosystem calls. So those happen quarterly on Wednesdays. And we are kind of assembling everything that has happened in the last 3 months since the last Prometheus and ecosystem call before that. And it's kind of a in-between update, because PromCon only happens every year. Maybe there's a KubeCon observability day or whatever with some updates, but this is kind of a continuing and really a stable way of getting a good feeling for what's happening in Prometheus, but also the ecosystem, exporters or side projects or other things like Thanos and Mimir, and I don't know, you name it. Whenever maintainers have something new to show, they show up and talk about these things there. So definitely join those if you want to. We also have a new Ansible collection that is completely written from scratch, as far as I know, and no, but it's...
No, we have improved it and moved it as an actual collection.
Okay, yeah, exactly. So improved it and made it an actual collection. Perfect. So if you're using Ansible, your life has been improved as well. And now what's coming? So we are going to see a lightning talk on the new Alert Manager UI, which is super exciting. Hopefully we'll get some more development on there and get new features again. So that's something I'm looking forward to as well. And then today at 15:45, there's a talk on the created timestamp, and those are just 2 examples. We'll have so many more, like the OTLP ingestion, for example. There's a talk there, and so many things. And we're also going to meet on Saturday with the Prometheus team and friends, and we're going to discuss everything that is kind of brewing in the ecosystem, and we'll see what we'll add to the list and how to move forward Prometheus in the next year. So that's what we had for the slides. Now it's time for your questions. Are there questions? Going once. That's what I do at the Prometheus ecosystem call. Going once. Going twice. No questions. Everything perfect. You're looking forward to all the updates in detail, I guess. And then you can ask your questions there, which is also good, because those people are actually know the things in detail. All right, so if there are no questions, no?
Make sure to check prometheus.io/community. If you want to find us, we have the calendar there, we have mailing list, we have everything that you need to know. And if you want to join, basically all the meetings that we do are open to the people who are using Prometheus and want to be involved in the project, so feel free to just join us. If you don't have the question now, but you want to ask it on the mailing list or anywhere, you can always do that. We are really, what I really like about Prometheus personally is that it's really open and we don't do much in the dark, so we really try to do a lot on the public mailing list and the public channel, so always feel free to ask us questions there. We are really open to discuss with you, to get the feedback from the community. And not only during PromCon, but like all the year, it's really super important for us to learn for the users and to get your feedback on anything that we do well or not well, of course. But so always feel free to join us in the meetings. If you have questions, if you want to just look at the meetings or just join, we are available all year round. We are a big team and we are really working from different backgrounds, and we really enjoy getting feedback from you.
All right, then that's it, and we'll be right back with the next talk. Thanks.
Thank you.
Not yet. All right.
All right.
Let's continue. Perfect. Okay, so we are at 45. We had technical issues, but we've resolved them on time. So first test, pretty good. I'm super excited for the both next speakers to be here and talk about Perses. I've been following the project since it was like in stealth mode of some sorts. So I'm super, super excited for what the both of you have to tell us today. Stage is yours.
Thank you, Matthias. Hello, everyone. My name is Augustin. I'm a principal engineer from Amadeus. I'm also part of the Prometheus team. And I will be with Antoine, who is a senior developer also from Amadeus. And together we are going to present a new tool called Perses. And I hope you will enjoy this new product. But before going deeper in the details, I just want to give you some details about where does it come from, the genesis of Perses. So actually, it's coming from a simple statement. If you are looking to the cloud-native computing foundation tools, like Prometheus and Kubernetes, you will see that, okay, you have the metric formats, you have Prometheus, you have OpenTelemetry, you have OpenMetrics, you have Thanos and Cortex to scale Prometheus, but there is nothing for the visualization. So that's where Perses is coming from. We want to fill this gap, and we want to go to the CNCF, and that's where we created the project. We created the project under the license Apache V2, and today it belongs to the Linux Foundation, and one day it will go to the CNCF. The project is supported by Amadeus, Chronosphere, and Red Hat, and maybe later with more and more companies, let's say. So let's go for a quick overview. First thing you should know, Perses is a dashboard tooling specialized in the metric visualization for the moment. So if you are going to try it today, you can only connect Perses to Prometheus or Thanos or any vendor supporting the Prometheus API, and nothing more for the moment. When we started to think about Perses, what we want to do with this project, what we want to achieve exactly, first thing that came on the paper was we want something really GitOps friendly, because, for example, in Amadeus, we have like 3,000 dashboards using Grafana, and it's quite hard to maintain all these dashboards and to be sure they are following the upgrade of Grafana. They are still good, they are still loading when you are on call at 3 a.m. We are hoping everything is fine. So we wanted something much more GitOps friendly and let's say dashboard as code oriented. So to be able to achieve that, we have 3 different let's say topics. First things we want to have is a static validation, which come with Perses with CLI and QLang schema. And with both of them, we are able to validate a dashboard JSON using any kind of CI/CD you would like. We want also to be native to Kubernetes, which means to be able to install the dashboard with CRDs and to have the data source discovery, and then we will think about other features to be Kubernetes native. For this part, it's ongoing, so if you are going to try Perses, it's not yet available, but it's going to be. And also, when you are going really on the dashboard as code mode, okay, you are taking care about JSON, you are using probably JSONnet and so on, but sometimes you just want to try actually your local dashboard before pushing it on the CI/CD on your Git repository. And that's why also we want to be able, to run locally the Perses binary, so you can edit directly on your laptop using the Perses binary your dashboard, your JSON dashboard. The next thing we wanted to have, and it's coming from a simple statement that if you are looking to Prometheus, if you are looking to Thanos, if you are looking to now to Perses, to PromLens, they are all sharing something we want to have is to display metrics with a line chart. And if you are looking to all these different repository projects, they are all using a different way to display a line chart. And as a Prometheus member today, it's quite annoying to move to a project to another and say, okay, it's a different way, so I have to change the way. It's harder to maintain because you have different library to display the metrics. So we wanted to say when we started the project, we say, okay, why not we are going to provide the different library to display the metrics, and maybe one day Prometheus, PromLens, Thanos, Cortex, they will be able to use the libraries to display their metrics, and we will have something consistent across the different UI, and we will have something unique, let's say. So the first one that was able to embed Perses was Chronosphere, of course, because they contribute a lot to the project on this direction. And after that, Red Hat considered this possibility, and they are actually ongoing. It's ongoing, sorry. They are going to integrate Perses in the OpenShift console. So they are not running the binary, they are really importing their package, the package Perses -dev dashboards and the panel plugin, to modify the OpenShift console and to display their dashboard. And maybe one day, when the project will be, let's say, in a stable mode, in something else than incubation mode in CNCF, we could think about integrated in Prometheus, in PromLens, Thanos, in Cortex, whenever we want. But for the moment, it's just an idea for Prometheus. I said at the beginning that Perses is a dashboard tooling specialized in metrics display. That's just the beginning, because we also want to display the metrics, the traces, sorry, and the logs. And so we have everything. We have everything in the single place. You are able to display any kind of data from the observability area. And it's ongoing, actually. The traces are handled by Red Hat today. And we hope that before, let's say, Christmas, we will be able to have that. And the logs will come a bit later. And now I think it's time to go deeper on the feature, what we are proposing today in Perses, and that will be Antoine that will do that.
Yep. Thank you. Yep, so hello everyone. Yeah, so first in terms of feature, for sure, we have charts. So let's say only a few basic types for now, like time series, gauge, and single stat. We have also bar chart and markdown panel. So of course, more will come later. But let's say those are the main ones that you can already use quite a lot to display a lot of data. Also, we have what we call multi-scope resources, so that's for and variables. So the idea is that you can define such resource at different level in the application, so either a global project or dashboard scope. And the principle is that when you have, let's say, a standard common use case, you will use the, let's say, higher scope to define a resource so that it's shared and available to many dashboards. And for the more specific things, you will use the lower scopes for the things that you don't want to be available externally. And so in case of conflict, once on a dashboard, if you have two resources from different scopes that share the same name, it's the one from the lowest scope that takes precedence. So maybe it will be clearer with an example. So here we have some, let's say, panel graph, so, time series graph, so that is powered by a demo data source and 3 variables. So you have a cluster, namespace, and pod. Basically, the demo instance, you can see that we defined one specifically for this use case, and the data source is defined in the dashboard. And by doing this, we are hiding another one that was defined in the project, which itself is hiding another one defined in the global scope. Then coming to the variables, so for the cluster ones, we want the full list of clusters, so we are fine using the global variable that was defined. For the namespace, we want, let's say, a restricted list of namespace corresponding to our application. So we are using a project variable here. And finally, for the pod, we have a specific use case here, so we define it in the dashboard so that it's not visible outside of it. We also have a feature of migrating, let's say translating a Grafana dashboard into Perses. So this was especially needed in our case at Amadeus. As Augustin said, we have thousands of dashboards, and we didn't want to start again from zero. So this migration is powered by Qlong schemas also, like for the plugin data model. And finally, as Augustin mentioned, so we have a CLI that for sure you can use directly to interact with the Perses API, but as you may guess, it's also meant to be used in CI/CD pipelines and this kind of thing for example, mass validation of dashboards or mass imports. Okay, so now demo time. Oop. No. First here. So here, this is a simple homepage of Perses, so nothing really exciting here, but let's say we have a display of, for example, the recent dashboards or the dashboards that were flagged as important by the admin, so let's say shortcuts. So so just to show you about this migration feature, so I will start with this. So we have this migrate screen here, so it's not very sexy, but actually it's something we plan to revamp fully in the near future. So I will just upload the, nope, not this. So the not exporter dashboard that I downloaded, that I previously downloaded from the Grafana marketplace. So there is it. We have just to provide a value for this template parameter here. So this is for the data source. So I will just put the data source name I want to use. I click on migrate. And here I have my Perses dashboard in JSON. So I just left to decide which project to import it. So Perses, import. No. Thank you, dictionary, but I don't want you. And here, so we have our dashboard available and working. So just to give you, let's say, a quick overview of what's possible here on this screen. So so looking at the edit mode. So to illustrate what I was explaining before with the scopes and the resources. So for example, this panel here, it has queries that rely on the Prometheus demo instance here. And you can see that this one comes from the project. And we have another one with the same name that comes from the global scope, but it's overridden, so you cannot select it. It's still visible for, let's say, user awareness, but you cannot select it. What else? We have the variables menu, for instance. So here you can see the variables that are defined in this dashboard. You can also see the variables inherited from the external scope. So here we have a job variable coming from the global scope that is overridden by local one. So again, you can still see it, but you cannot use it. And also, we have the display of the built-in variables. So you know that as in Grafana, so we have, let's say, built-in variables provided by Perses. And here it's well, you have the full list, so just for, let's say, user awareness, so which syntax to use to invoke them and what's their purpose. Then, yeah, you have a bit of time, yeah. So just to show you quickly, so for the, let's say, project resources, so it is the project UI, so here you have the list of dashboards for this project, but you have also the list of variables and data sources defined, and we have the same kind of UI in the admin section for the global resources. Yeah, that's pretty much it. And yeah, and unfortunately, so I won't be able to show it to you because of the technical issue, but yeah, we had an example of the embedded use case in OpenShift UI, but yeah, so I won't be able to show you this. But basically, you're able to see graphs, and you also have the drop-downs for variable selection and time range and the refresh interval integrated in OpenShift. Yeah, I think that's it.
Cool, thank you. So actually, it's not finished. I just wanted to share to you the top right. Ah, yeah. No. There? No.
No, the one, but do a normal click on the three dots. You did it right.
So what?
Yeah. Yes.
Ah, yeah. Thank you. Thank you. I just wanted to share as the last thing the roadmap of Perses, what we are going just after the PromCon. So we have three major features, let's say. The first thing will be authentication and authorization. If you are going to try today Perses with the sandbox or just locally, you will find quite quickly that you can delete the dashboard from your colleague without any restriction, which is not super great. But so, yeah, we are going to take care about that by supporting Azure, Google Cloud, AWS for the authentication, and the authorization will come at the same time. Like I mentioned at the beginning, we want also to support traces and log visualization. It's already ongoing, and it's handled by Red Hat. And also, we want to tackle with more resources how we can package the plugin, because today, if you want to develop a plugin, you will need to build entirely Perses to see your plugin appears in Perses. So it's not super great, because that means or we have to support your plugin, or you have to rebuild entirely Perses. So that means we want schema versioning, because we still want to make some evolution about the current plugins. So we want to tackle this part, how you can migrate from a version to another one. And also we want hot logging of the plugin, so you don't have to restart Perses every time you want to change the plugin or add a new one. So that will be the three major features, and the minor one, expecting the last one, the documentation, please don't consider it's a minor one. We expect why just after that. The first one will be observability data explorer. So we want to start with Prometheus and the metrics. And I'm pretty sure we'll take some inspiration from the famous PromLens, because well, from my perspective, it's a great metric explorer. We are going to support the subfolder management, which is already possible with the API, but not in the UI. So we have to fill the gap. We want to support the data source discovery with Kubernetes. Of course, M-Chart, it's already ongoing, it's available, but well, it still needs to be supported and evolving. We are also going to implement a Perses operator. Today, the repository is empty, but that's because we just created to start the project. We want also to support panel generation. It's actually from Parker, I think. This idea about the SLO because, it appears that for SLO it's always the same kind of panels you want to display with the same metrics, so actually you can generate it, and it's quite painful to do it manually each time for every metrics you want to support. And finally, documentation, because if you are going to try Perses, maybe you will find it in some way harder to use it, because probably some part you will find harder to understand what's going on, and that's because there is no documentation, so you have to try it on your own. But it will be also a good feedback from you if you are going to try it, because then we can know exactly where you are struggling and improve this part. So if you are going to, if you want to try it, if you want to know more about this project, it's available on GitHub under the organization Perses. We have a live chat on Matrix if you want to chat with us. And finally, if you want to contribute, we have the documentation that should help you. And that will be the end for me. Thank you very much for your attention. If you have any questions, that's the moment.
No questions. All right, then I have a question. So you talked about a Perses operator.
Yeah.
Have you considered building like a KCP API? Are you familiar with KCP?
Not that much, but...
So, okay.
Sorry.
With operators, you're like bound to the cluster, but with KCP, you can build one API that's like global for all dashboards, let's say,
okay.
So that it's not bound to a cluster. And I always felt that would be a more natural fit.
Okay, that's interesting. No, I didn't know. So yeah, maybe that's something we should consider.
Cool.
Definitely.
Let's chat.
Thank you.
Thanks for the presentation. It was really insightful. I wanted to ask, how was the experience with migration from dashboards from Grafana? Because my experience so far is that every major version of Grafana, the schema changes quite a lot. So you are supporting all versions, or there is a specific version that you are focusing on?
So for the moment, we are supporting only the last version of Grafana, but that's because for the moment no one is using Perses. So that was easy to say we are supporting the last one, and that's it. And also because in Amadeus we are always upgrading Grafana to the last version just right after they release it. But I think we need to support different kind of version of Grafana. But if you want, also I can have a different argument. Let's say first migrate to the last version of Grafana, so you will have to migrate all your dashboard to the last version, and then you can migrate to Perses. That's not a nice, nice way to present Perses, but for the moment that can be that. But yeah, we will definitely support our version of Grafana.
Thank you.
There is a question.
Which data sources does Perses support right now, except of Prometheus data source?
What do you mean about recesses?
Data sources. I mean, like Grafana supports
only Prometheus today.
Only
It's
Prometheus?
supporting. Well, if you are using Thanos, it's working. If you are using Cortex, it's working.
Are you going to
Any
it?
wonder that supports the Prometheus API, it will work. But excepting that, no, nothing else.
Are you going to it other data sources which are not Prometheus compatible?
So for the metrics, you mean?
Yes.
I don't know. honestly, I don't know, because we don't have so much resources and contributors. So for the moment, we are focusing now for the traces and logs. But over metrics, data sources, I don't know. If the opportunity came, why not? If not, it's not on the plan.
I see. Thanks.
Thank you. Great work you're doing here. I was wondering, have you considered displaying alerts somehow for maybe like points, alerting, integrating with Alert Manager?
That's quite funny because every time I'm talking on Perses, everyone is asking me, should we support alerts? And but I will say, why not? But yeah, still it's not on the plan. So, and I think some guys in Amadeus also directly in my team want that. So probably it will happen.
One last question, then we need to wrap up.
Yeah, thanks for the presentation. So will there be a way to customize the look and feel of Perses? Will every project that adopts Perses, is every project going to look the same? Or will there be some theming mechanism or some way to customize the way that components look?
That's a really good question, and unfortunately we were not able to show the Red Hat video that display how they are integrating Perses in OpenShift, and that's quite unfortunate because you will see it doesn't look at all the same. So for the moment I don't know how they do it, but it's going to happen and to be documented, I hope. So I can't really answer, honestly. I don't know how they did it, but I hope they will explain soon. Sorry.
All right. Thank you for your talk. It was amazing to see the progress you've made since I last seen it. Incredible work. I guess there were more questions, but both of you are going to be around for the rest of PromCon.
Yeah.
So you can always find them and ask the questions. And yeah thanks.
Thank you very much. Thank you.
All right. That was a quick change this time, so I'm happy that it worked right away. Next up are Gautam and Jesus, both Prometheus team members, and they've been working on some very exciting new capabilities for Prometheus, which we teased earlier, but I'm happy to learn more about it now. The stage is yours. Thank you.
All right. Hello, everyone. Hi, I'm Gautam. I'm a product manager by day, but I still like writing code, so I'm a software engineer by night, or at least I like to think that I am. Yeah.
Hi, I'm Jesus. I'm a software engineer at Grafana and Prometheus team member since this year. And over the last 2 years, I've been working on maintaining the TSDB, out-of-order support, and now OpenTelemetry, or trying to make Prometheus support OpenTelemetry natively. I'd like to start with this chart. So I took this screenshot a couple of days ago. This is the Grafana Cloud's growth in terms of like the amount of organizations that are adopting or trying to use OTLP metrics. So this does not include traces or logs, it's just metrics. And we've seen like a 2.5 times increase without like much effort from our side. So it seems that there's interest in the community for this. And we're also getting questions about like what's the status on the OTL SDKs, like their support for like sending metrics to Prometheus. And so it's a topic that's gaining traction and yeah. But the thing is, for those of you who don't know, like OpenTelemetry is a spec, so it defines like how you're supposed to observe different observability signals, such as metrics, traces, or logs. But it doesn't provide a backend. And like users that want to use like their favorite metrics backend, Prometheus, when they try, they see that it's sometimes not the perfect fit. Like there's some things that don't work as expected, and also, yeah, maybe sometimes there are some samples dropped that shouldn't be dropped, and sometimes it's hard to like see the actual data that you send it. Yeah, and that's the image that's the pull request that Julian was referring to earlier. That's the very, very, very experimental OTLP native ingestion endpoint that we have just added to Prometheus. So we're getting there. And now I leave it to Gotham to like show you a quick demo where you can see some of these issues I was referring to.
Yeah, so basically, OpenTelemetry is a spec. It has a data model, and this is kind of how the OpenTelemetry data model looks like. For example, if you have a service that's pushing data, you have a bunch of attributes called resource attributes that kind of tell you details about where the service lives, what the service is about, and things like that. And then when this service or instance pushes metrics, these are normal metrics with labels, but it says, oh, all of these metrics are coming from this resource attribute with these resource attributes. The resource attributes are kind of like target labels in Prometheus, like Kubernetes cluster name, namespace name, and things like that. Cool. So now kind of let's look at how the spec defines this to be stored in Prometheus. So I have a Prometheus server running, and I instrumented, I instrumented one of my services to expose one metric, which is the HTTP request duration histogram. And if you kind of try to take a look at what this histogram looks like, it has the method, route, and status code. But it actually doesn't have any of the resource attributes that tell it where it is coming from. So the spec defines the resource attributes to be stored in a separate metric called target info. And the target info is this massive metric. For every instance, we just take all the resource attributes and put it in this target info metric. So now, if I want to use this information, let's try to use this information. It's going to be hilarious. You will see why. So I want to measure the rate of requests over the last 2 minutes, and I see, OK, there are different rates of requests. For hi, hello, 1 service is having some QPS and stuff like that, but I kind of want to see the rate of requests on a cluster basis, like on group by cluster. For this, I need to do something called joins. So let me try to join on target info. That won't work because, joins, who does them? Wish me luck here. Maybe this will work. Nope. I have to do something called group left. Oh, it did work, but not really. We need the cluster name. So I'm going to say, OK, group left by k8s cluster name. And the cluster name gets added. Now we do a sum by. I love the autocomplete on this one. HTTP status code. this big-ass query, and then I graph. And then I can kind of see, maybe for the last 10 minutes when I kept the demo running. Nope. Yeah. All right, so I can kind of see that prod US central 0 has 6.5 requests per second. Prod US 2 is lagging behind a little bit, and I can also see that, oh, only prod US central 0 is having 500 errors. So this is a very common use case. And this is the bonkers query that you have to write to handle this use case. I don't want to be writing these queries, and this is a simple thing to do. And suddenly it's super complex. Yes, there are ways to get around it. For example, the OpenTelemetry Prometheus exporter gives you a way to copy all the 40 resource attributes into every single metric. That is also not a great experience. So yeah, this is a highlight of what the current state is. Cool. Yeah.
Right.
Yeah. 1 second, I think you clicked that button. Yes.
Yeah. So it's time to build things and try to fix this. So you'll see this slide 2 times, one here and now, and then another time at the end. It has 3 links, so anyone interested in this topic that wants to contribute, you go to this slide and you'll find everything you need. First link has a list of like the UX issues we found, and like it's a public document, so like you can suggest, and if there's anything that you're already using this and there's something that is not mentioned, feel free to add it. The second link has a list of like all from the things from the first document, which ones we think are a must-have, like to be native and a great experience for the user. And then it has another list of things for like the nice-to-haves. So maybe not to do on the next year, but over the course of time, you know. And the third thing is the thing we are working now, which is we are trying to map all those issues into the Prometheus tracker. So there is a milestone called OTL support, I think. And yeah, we are mapping all those issues. So yeah, feel free to work on that. Help wanted, I'll be there. Right. Yeah, and we have, like, now we're going to dive in some of those issues, like to give you an overview of how what these issues look like. So the first thing is push versus pull. You know, Prometheus has always was meant with the pull-based approach, and that kind of gave us, there's a bunch of things that people don't think about, but for example, service discovery, like if you had 50 pods in your infrastructure, service discovery will find them, and if 2 were down, you will exactly know which 2 were down, because you know you have the names and everything. So that kind of gave you the app metric. And also, like if suddenly any of those pods got to a newer version and it started instrumenting like 1,000 new metrics, you could protect your Prometheus server by setting the right configuration so it wouldn't crash, because like you have limits configured, and if you scrape those pods, like it will just protect your server, right? So you would have, you would know which services, like it would be a more reliable setup because you know which pods are up, which are down, and also, yeah, if they go beyond the limits, you're safe, right? But with the push approach from the OTL native instrumented applications, you don't have those protections because you don't have, you don't know which are up or down because you're not like service discovering them, and also you don't have like the app metric. But we think that we can build it. Like we can probably leverage the service discovery. Like we can do a mix of service discovery with the push-based approach because in OTL like recommends to from the SDK when the metrics are pushed, like it pushes every 60 seconds. So we can, by adding some logic to Prometheus, we can know if a pod has missed like 2 intervals of push intervals, it's probably down. So we can just track the pods that are supposed to be there. We can just check which ones are sending data, and then we can have an app metric. So like we can build the same feature that we don't have right now. Yeah, and another thing, the pull-based approach only has configuration on the server side, but the push-based approach from OTL like would require configuration on the Prometheus side, but also on the clients. So like that's an overhead for the user, but yeah, so we would have to probably come up with decent documentation for the user. But so this is something also that needs to be done. Right. The second thing, proper handling of resource attributes, like Gotham explained this very well in the demo. I underlined, so that's a P95, like histogram query. Most of you probably are familiar with. And we want to see like the P95 of that metric, and we want to see by availability zone. But because we don't have the availability zone on the series, we have to do the awful join. So yeah, so ideally this query would just work without the underline part. And as a Prometheus user, what I would do to achieve this is I would go to my code or wherever that metric is being produced, and I would put the availability zone into the series as a label, right? So this is precisely the feature that we want to give to users. We want to give like some sort of configuration for Prometheus where you can say, copy this list of resource attributes from the target info metric into my metric on ingestion time. So you don't have to do anything other than properly configure your Prometheus instance. And yeah, and we can, so there are a list of attributes that are default by the spec, but you can also have custom attributes. So you could add them to that config and it would just happen. And then you won't have to do the joins. Right?
Yeah. The other interesting thing about OTL is it has support for dots in metric and label names. So whenever somebody defines http.server.request.duration in their code, when it ends up in Prometheus, we have to convert all the unsupported characters to underscores, which is confusing for developers. Why is what I'm defining not in Prometheus? So we are adding UTF-8 character support to Prometheus, but I do want to mention something. Why do I say it's UTF-8? That's because OTL supports UTF-8. This is a valid metric. It's not dividing service metric by version metric. This is a valid metric in OTL. And you can define this in the SDK. But this is also a valid metric in Prometheus. That's not service minus version. That's one metric name. But we will kind of have to support this because we don't know how users will be using OTL and how they will be defining their metrics or where these metrics are even defined. Cool. So yeah, we want to expand Prometheus to support most of the common use cases of the OTL character set. Yeah.
Yeah, out of order. This topic keeps coming back to me. So out of order, yeah, OTL instrumented applications typically write to a collector, and then the collector writes to the backend. And so this is because the collector encourages batching up writes. So like, I don't know, I want to receive 100 metrics before I send them. And the reason for this, it makes sense from the client perspective because like then compression is more effective, and also you have less traffic, less total traffic over the wire, so it also optimizes for bandwidth usage. But the problem with this is that it puts pressure on the backend. You now have to handle higher payloads, and also the moment you have multiple collectors on your network, on your topology, you're probably going to have out of order because the collectors are not going to wait on each other to like push the metrics. And also, the moment you have a failed request and you retry it, you're going to get out of order. So I think we cannot exist without it in the context of OTL. And it's not a blocker because, fortunately, we announced out of order as a feature in last PromCon in Munich. And it's working, but it's still experimental. So the work to be done here is probably to like finalize policy in some of the rough edges. Like there's a bunch of issues. We have made sure to put those issues into the milestone. Yeah, and possibly produce some documentation as to like if you're using OTLP writes like OTL ingestion, the native ingestion, like how you should configure your server to make it work, and probably just enable probably 5 to 10 minutes of out of order is enough.
Yeah, remote write. This is a format that has had major changes in a long time. But funnily, we only called it stable this year. So this is a benchmark of scraping 4 million active series and then sending them over OTLP and sending them over Prometheus. How many of you think that the blue line, which is the number of bytes or MB, is Prometheus? Okay, a few people. Well, it's not. It's actually OTLP. So OTLP uses 50% less egress compared to remote write. However, it uses ZZip, which is mostly doing a lot of the work, while Prometheus uses Snappy, which means you also use a lot more CPU. It's like 30 to 40% more CPU. And we actually made this comparison when we designed remote write 5 years ago. And at that point, we decided that CPU was more expensive than network. I think that is changing slowly, hopefully. So basically, we are looking into making remote write more efficient and maybe even adopting OTLP. One of the reasons for that is there's a new Arrow implementation of the OTLP protocol, which uses half the bandwidth of the non-Arrow implementation, while also using half the CPU of the non-Arrow implementation. I put an arrow there for the Arrow protocol. So this is also, I love the fact that this is happening. This is also pushing Prometheus to innovate more, and also we probably will have a remote write 2.0 because of this, and I'm really excited for that. Delta temporalities. 2 days ago, I published a blog post on delta versus cumulative temporalities and the trade-offs between the two. But the thing is, in OpenTelemetry, you have both cumulative metrics and delta metrics. How many of you understand the difference? OK, a few of you. So if your application is exposing a counter, HTTP request total, the way your application exposes it to Prometheus is the cumulative value. It's like 10, 20, 30, 40. It's like an ever-growing value. But if you're coming from a system like statsd, you actually push the deltas between the last value and now. And basically, OpenTelemetry supports both. And it says that the delta metrics are more efficient because you don't need to store state in your application. So if you see a delta of metrics, you just push it, and then you can kind of remove that metric from memory if it's not being updated quite a lot, which is fair. But I also see a lot more use cases for delta. This is an example of the delta. So the upwards is how the cumulative value looks like, and the downwards is the lower one is how the delta value looks like. How many of you tried monitoring Lambda services with Prometheus? Okay. Okay, nobody tried to monitor Lambda. Okay, interesting. It's a good reason, because then you would bang your head against a wall because Prometheus is not exactly built to monitor Lambda services. That's because with Lambda, you have an invocation ID, and the cardinality just blows up. And this is one example where Delta can kind of help you monitor things, where your applications just push Delta, and then in Prometheus, you aggregate that into the cumulative value. The other thing it will also help is aggregations and to reduce your cardinality. So yeah, we do want to support delta temporalities in Prometheus. Hopefully, we'll see. So we said time to build things, but honestly, it's time to build things after the Dev Summit on Saturday. Because a lot of the changes that we are proposing here, they're very exciting, but they're also massive changes. We are going to make Prometheus a push-based system. And this is a fundamental change to Prometheus. We are proposing to add delta temporality to Prometheus. This is also a massive change. So we have a nice discussion that's going to happen on Saturday, where I hope we get consensus to do a lot of these cool changes in Prometheus. And once we have approval for some of these changes, let's get hacking. So we have time. Is that with Q&A or without Q&A? Oh, it's without Q&A. Any questions so far? All right, you have a question. Yes.
Yeah, about making Prometheus push-based and the up metric. Some clarification would be good around, like, is that recommended to be using primarily with push, or should we, still tell Prometheus users to primarily use pull, which I'm a big fan of because of service discovery, and then coming to the up metric that was mentioned earlier, where just checking if an update doesn't come in twice, now it's down. We don't really know, is that supposed to be gone now, or did something that never pushed something, should we be able to detect that as well? Is there some kind of service discovery support for this path planned as well, so we can actually know what is currently supposed to be where?
That is a good question. So basically, it's going to work like pull. We discover everything that is supposed to be pushing, and then we watch for the pushes. If we don't see a push for 2 intervals, we mark it down. That is the plan. That is the idea in my head. Somebody needs to write a design doc to explore all of these. But what I really like in OpenTelemetry is that the client SDKs they're building a remote configuration protocol And I'm hoping Prometheus can push down the configuration to the SDKs as well. So if Prometheus is becoming overwhelmed, you can say, don't push every 60 seconds, push every 120 seconds and stuff like that. So it is going to be a big shift, but I think we can make it work. I mean, yeah, but we have to see. Somebody needs to write this design doc and think about this for 3 days or 4 days. Yeah.
But you don't want to get rid of pull.
No. This is no. This is yes. Yeah.
Yeah.
Oh, so yeah. So Julius, no, I don't want to get rid of pull. I love pull. I'm going to try my level best to make sure that the best benefits of pull are existing in the OTel world as well. Yeah.
So to correct there, so to help answer your question as well, like we want to leverage the good things about pull that we already have, like service discovery and the app metric, and build that for the push-based approach, but not like replace one thing with the other, just like have both. Yeah.
Cool. We also had a question there. Yeah.
Do you have more slides?
No.
Okay.
The question is, which library for OpenTelemetry do you use in Prometheus? The official library of Go library from OpenTelemetry community?
So we don't use the instrumentation libraries in Prometheus at all, but we use the collector code, which converts from OTLP format to remote write format in Prometheus.
And the question is, how much the Prometheus binary size increased after you added this OTel library into Prometheus?
It's a good question. I have no idea. But I don't think it's a lot, because Prometheus pulls in the universe already. So it shouldn't be a lot, yeah.
Why I'm asking this question? Because in our case, the binary size increased by 10 megabytes, and it was more than 50% of our binary.
Oh, wow. Yeah. You had a question there, I think.
For the bit you were talking about to do with the querying side of things, with the joins and what have you, you said about potentially changing things so that it added the labels in at ingestion time. Have you considered doing that at the query time instead? Because we already have this sort of issue to a certain degree where people are using machine metrics to do similar things, and therefore maybe doing it in the query to solve both or make it nicer for both use cases would be nicer, instead of having to remember to do that and then, oh, I've got old metrics that don't have that label and all that sort of pain there.
Jesus, you want to take it?
I don't know what to answer really. So I think we thought about this, but then you have to like search like into more blocks probably, right? And pull in more data and like abstract that complexity from the, I don't know. We feel that doing that on ingestion time would simplify things in the Prometheus code base itself, like because, but yeah, like, I mean, this is a valid proposal. We actually, so the way this is going to come down is probably in the next month or month and a half, like we'd like to write a doc. And what we said is not like the definitive proposal, it's just one of the ideas. So like just like if you want, bring this as a proposal and we consider that, and yeah, we just like, yeah, I cannot answer right now because we need to know the implications, what will be best, yeah.
One of the oldest issues in the Prometheus repo says, simplify joins, please. And I agree, but yeah, nobody has basically thought through this on how we can do that, and yeah, we would love to collaborate. Yeah, go for
Hello.
it. Yeah.
In the milestone that you have in Prometheus repo to support OTel, is there anything that is very obvious that you need Prometheus 3.0?
I think there's nothing obvious other than adding documentation.
Give me a second. Prometheus 3.0 for this. Maybe if you want to simplify how we support UTF-8. If you want, like, the current way is we have a proposal that's open. I quite like it. But if you want to make the dots and stuff native to PromQL and make it extremely simple to use other characters, I think that might require a 3.0. That might. We try really hard not to break things. I like the Go model where they say there will never be a go-to. Yeah.
Do we have more questions? Do we have more? Yeah. I mean, we have a break after this anyway, so, but we also want to take time for the break because we are going to have some bagels, I believe. What was the question?
So I'm not familiar with how the OTel protocol works, but when you talked about the push model, is there going to be support for UDP as well, or is it just strictly mostly TCP?
That's a good question. The OTLP has HTTP and gRPC, so they're both TCP. I don't think there's a UDP in there.
Gotcha. An arrow? What does arrow?
That's also gRPC, I think.
gRPC,
yeah.
okay.
Yeah. One more question, yeah.
You already had one, so first.
My question is, what are the benefits and the trade-offs of switching from push to from pull to push?
There are none, but so basically we are seeing customers and users and stuff, they are gravitating towards instrumenting with OTel because they like the premise of not having vendor lock-in. They like the fact that there are semantic conventions. And when you use OTel, the mental model that you use is push. OTel does support pull, but all the documentation says push. So it would be swimming against the tide and an uphill battle to convince users, hey, use OTel, but use pull with OTel. That's basically, when we are trying to be OTel native, we need to support push. But I don't see any benefits of push. But I'm also a long-time Prometheus maintainer, so I'm not biased at all.
We love pull. Pull is going to remain.
Yeah.
So you can keep it.
Do you have your question?
Oh yeah, yes, except for deltas. Yeah.
You showed on one slide that OTel protocol requires less network bandwidth than Prometheus remote write protocol, and you're exploring that it would be great to add support for OTel protocol into into Prometheus. And the question is, probably it is better to just replace Snappy protocol with the Snappy compression with the decompression for Prometheus remote write protocol, and this also reduces network bandwidth by up to 5 times.
Yeah.
We already
so there is an effort.
experimented.
There is an effort for this. There is people. I think Callum couldn't make it because he's on PTO, but there's a document describing this for remote write 1.1, where we are trying to add other compression algorithms, and then you can choose. So there's a group of people that's trying to build that and test it with remote write 1.1, yeah, and then produce a benchmark. And that should, I think we are close to that. It should happen.
Yes. So yeah, the comment is it's probably much easier to do that than use OTLP. I fully agree. I am putting this graph in front of everyone to kind of force people to be like, oh shit, we need to improve remote write. It doesn't need to be OTLP. If you can kind of come up with something that's better and faster than OTLP, let's do that, but not OTLP. But we should basically be more efficient, or at least as efficient as OTLP. Yeah.
Okay, that is it, I believe. Thank you so much for the both of you.
Thank you.
And yeah, we are at 10:45. We are meeting back at 11:15, so half an hour. There are bagels and mini bagels and bread in the other room. You can have lunch and bagels and drinks, everything in the other room. Please don't bring any drinks, etc., into this room. And we are back at 11:15 for an eBPF talk.
All right, we're going to go and get started again. So now we have a topic that's very near and dear to my heart, eBPF, and I'm excited to hear more about it. So give him some hands.
Thank you very much. Thank you for the organization also. My name is Mario Macias from Grafana Labs, and today I will introduce you Grafana Beyla, the product we are working on, and how it can provide metrics and traces from your application using eBPF and export them to Prometheus. So imagine a legacy application which is not instrumented, and you just want to get some metrics from it. So in the best case, this is a very simplistic graph, but if your application uses a runtime like JVM or .NET, you can insert an agent, and with a bit of extra configuration, you can push or pull your metrics from Prometheus. But what happens with compiled languages like Go, Rust, C? If you want to instrument it, you need to get your code and add some instrumentation points. Then you rebuild it, you get your instrumented application, and it's ready to work. But with legacy applications, all code, it's not always easy, because you maybe don't have the time or the resources, or, for example, you are using an old version of the compiler or the runtimes, and you don't have source level compatibility with the newest, latest versions of the instrumentation libraries. So Beyla comes here to fill this gap, and by means of eBPF is able to attach to some events of either the operating system or also your application, as well as its runtime and libraries, and provide the metrics for you without requiring to modify your application. You just need to deploy it with them. eBPF is a fancy word. The first time I heard it is eBPF, what? So let me first demystify a bit, talking about what is not eBPF. It's not magic. It's not something you can say, okay, I have a query language, please, eBPF, show me all the information I want, and format it to me so I can parse it automatically. Is not something like that. What's more eBPF? For me, eBPF looks like more a set of peepholes you have in the kernel, or you can set in your application. And once you look into them, you can see the matrix there. Fortunately, if you know where are you looking into, you know how the binary data is structured and organized, and then you can extract it. So eBPF extended Berkeley packet filter, but someone noticed me that it is not. It was the original name. Now it's eBPF. Doesn't have anything to do neither with Berkeley nor packet filters. It's a just-in-time virtual machine at the Linux kernel that allows you to hook some proof programs in multiple events of the kernels, in the libraries, in the user space programs, even in the network stack. So let's you see, even modify the memory at the runtime. But you need to know, as I mentioned, how the memory is organized at the binary level. That means that what you look from eBPF will be different according to the language, the compiler, or the architecture. That means the argument, the data structure, the local variables, the return values. More or less, all the mainly languages follow similar conventions, but not all the languages or the compiler versions follow the same conventions in the way they structure this binary data. So you need to know what you're looking and how these programs you are inspecting are compiled. This is an example. Imagine we want to trace each new TCP connection in eBPF. So we first need to know that this TCP connection is handled through a given function in the kernel. So once we know which is this function, which arguments it takes, which return values it has, you can write the BPF probes for it. BPF probes are usually written in C. I've seen some libraries that allow do it in Rust, but the common language is C. And you need to compile it not for your native architecture, but for the BPF instruction set. So if you want to monitor that, you first need to deploy in the user space as a regular, as a process in native code, the monitoring process, the process that will load these BPF probes. So the compiled language or the compiled binary is inside this native, as a data structure is inside this native monitor. So it will, through some system calls, it will load it into the kernel. It will say, okay, please attach this BPF probe to this kernel event, like is the TCP connect. So this BPF probe then will be executed every time the TCP connect function is executed and will communicate with with Beyla, in that case, with the monitor process, through eBPF maps, that is hash maps, ring buffers, etc. And then the Beyla, in that case, gets all this information, processes it, and then is able to forward it. The advantages of eBPF is that it is fast. It is just-in-time compilation, so every probe is executed at the native speed. It is stable. That means that programs are pre-verified before loading. It prevents unallowed memory accesses. It prevents, sorry, this is a typo, it prevents infinite loops. So you can safely load it without hanging your kernel. And even if it is clean, if, for example, your monitor program crashed, all the probes will be automatically cleaned up, so you won't pollute your kernel. It has some disadvantages. It is hard to debug. A part of printfs into a file in the kernel. I don't know any other alternatives. As I mentioned before, your probes are often dependent on the implementation details, whether the arguments are passed in the stack versus the register, the architecture, language, compiler conversions, big endian versus little endian, etc. Some changes in the inspected APIs also can break your code. If they push another version of the executable with different APIs, it can break your code. For example, with Go 1.16 to Go 1.17, they changed the way the arguments were passed. It used registers, then it used the stack, or vice versa, I don't remember, and that made that any new Go program will not be instrumentable with the old eBPF code. Another issue is that you need at least sysadmin privileges, because you need to do some system calls to load this code into the kernel. Let's talk about Grafana Beyla. Once we have demystified eBPF and agree that it's not magic, let's show the magic of of Beyla. Joking. So Grafana Beyla allows or automatically instruments your services and clients and provides metrics and traces for them. It is able to instrument Go executables, inserting probes into the user code. Now we are able to instrument HTTP, HTTPS, and gRPC services. And for other languages, using the kernel, hooks probes into the kernel, we are able to instrument HTTP for, I'd say, any language we've tried, and HTTPS for almost every language. I'd say all but Java. At some point, more protocols are going to, and languages are going to come. Grafana exports the data as red metrics. This is request, errors, and duration for every HTTP request, as it is able to export either as Prometheus and OpenTelemetry metrics, and also it's able to export this information as OpenTelemetry traces. This is the current supported Prometheus metrics. They follow some common convention you might have seen, for example, in the previous talk. And it also exports internal performance counters, which are not very relevant, but in case you want to see how Beyla is working. So let's do a quick demo. I have an Nginx server. This Nginx doesn't bundle any kind of plugin or special configuration. I just did apt install Nginx. Then I configured it for HTTPS to communicate via HTTPS. And I loaded just a web page template I found in the internet just to see how it works. So let's start Beyla in this host, and let's see how it is instrumented. We try to put a lot of emphasis in the adoption easiness. So you only need 2 properties to start running Beyla. One property is to tell Beyla which executable you need to instrument. You have 2 options. The first option is by the name of the executable, or maybe it's easier by the open port. So I will tell Beyla that I will ask Beyla to instrument the executable that owns this port. Then you need a way to tell Beyla how to export the metrics and the traces. So for the metrics, we will use, of course, Prometheus. So I will tell Beyla to expose a Prometheus endpoint in this port. And just for debugging purposes, I will tell Beyla also to print the traces in the standard output. So I run with these properties, I run Beyla. Okay, we can see these errors you see. Don't worry about them. They are not actually errors. But let me clean the buffer. So I will just start interacting with this application. Okay, you can see here it printed 2 traces. You can see, for example, the duration of the trace. This is the return code, the method. This is the path, and then the source and the destination. You can see also, if it were a post request, you will see also the size of the request, and here you can see the executable that is doing it. So let me just play a bit more with it, and we should see some other metrics. Let me reload. Okay, you will see. So let me just, in this metrics endpoint, okay, this is the demo. Okay, it should show some. This is the demo effect. Okay, that's super cool. Let me just try to, maybe, since this is a virtual machine, let me just try. Okay, that is probably because I did a typo. Yeah, sorry. This is not Beyla Prometheus metrics. This is Beyla Prometheus port. At least you see that I'm not faking the demo. Okay, so let me play a bit more. And you will see here, then, okay. You can see here the Prometheus. This is with the simplest configuration. You see some labels, but let me show some extra configuration you can provide. For example, you can provide a YAML file with all this information. You can see how to export the metrics. You can also see how to specify how to export the internal metrics, just to know how Beyla is performing. And also, it allows report the HTTP target. But if you want to avoid cardinality explosion, for example, you can group those traces or those targets into common roots. For example, I say that anything that is any image, just please report it as this, not the whole image, so you don't get an explosion of labels. So let me run Beyla here with this config parameter. Let me just play a bit more and reload. And you will see Beyla with the new extra attributes like the root. You can see here that, for example, in that case, the roots that are recognized are reported as roots, and the others that are not in the list I sent are reported as normal HTTP targets. You can configure. If you want to, instead of reporting the whole path, you can just report or not report it, or report an asterisk or whatever to avoid cardinality explosion. So thank you for your attention. That was the demo. I'd like to conclude that, okay, Beyla doesn't provide the same granularity as instrumenting manually your application, but it provides you an initial point or an initial step to get instrumentation without having to deal with the complexity of integrating the agent or the libraries into your code. So thank you for your attention. If you have any question.
Finally, people have instantly questions.
I would like to ask you if Beyla is running only on bare metal. I mean, this kernel module needs to run on a bare metal, or it can also run in a containerized environment. And if it does, then what is the impact of Beyla, for example, in a containerized environment? What's the performance impact, for example, in a bare metal server that acts like a node in a cluster? Thank you.
Thank you for your question. Good questions. Beyla can run in containers, but either Docker container or Kubernetes pods. But they need to be privileged containers, and also they need to share the PID namespace, the process ID namespace of the container they are instrumenting. With respect to the performance, I don't want to provide you anything official because we already don't have it. But our initial calculations is that is low. I wouldn't say low, okay, but as a comparative measurement, for example, there are some interested people using languages like Python or Ruby because Beyla, the overhead of Beyla is lower than some libraries that are written in non-native languages. But the official performance impact will need to be released because we at the moment have only very synthetic performance benchmarks. You mean a ping service with millions of requests per second, and then the measurements are not realistic.
Hi, thank you for the very nice presentation. My question is, how far can you push the boundaries of automatic instrumentation? So you have shown that you can instrument communication primitives like HTTP, HTTPS, Google RPC. What about different functions like memory allocation, free, etc.? Is there any plan, and how far can you go?
Yeah, we believe, but I don't want to give any. At the moment, we are researching on that, but it is possible as long as you know where to hook. For example, you can instrument the code runtime, know the garbage collections, or get other runtime metrics. You just need to know where to hook, and it's not as simple as just hooking to a given event. Maybe you need to hook into different layers and then match the data. To be honest, I thought the boundaries were much tighter than we are finally discovering. So as long as we keep learning about eBPF or learning about the systems, we see that the boundaries grow. Yeah, we with eBPF, and I hope so at some point Beyla can do it, you can get these kind of metrics, extra protocols like SQL, Kafka, and so on, but also get information about the runtimes.
Great.
Thank you for your presentation. I do have two questions. So the first one is, can one process for Beyla instrument two or more applications at the same time, or is it only just as a sidecar to the application?
Currently is one Beyla, one process, despite Beyla has a system mode in which is able to instrument everything. But we are currently working on being able to instrument multiple processes with one Beyla. It is in our roadmap. If you join this GitHub site, you will see the current status of the different tasks. Yeah.
Thank you. And the second one, why not Java? Or can it instrument JVM and Java processes?
We can instrument HTTP on Java, and we can instrument multiple parts of the JVM. But in the case of SSL, of TLS, Java uses its own library implemented in Java for TLS. So instrumenting with eBPF code from the Java virtual machine is really, really complex because you get just-in-time compilations or you can get interpreted execution. So you need to listen to multiple events. It is part of our research. So the Java virtual machine will also provide some extra hooks. So maybe you can listen to these compilation events and so on, and at some point you can. But this is a lot of work, and at the moment we haven't had the time to work on it.
Last question up there. We need to make it quick.
Hi, I'd like to ask, since it's instrumenting HTTP metrics, does it, and traces for HTTP, does it also support context propagation injection?
Very, very good question. At the moment, we are able to acquire the context from the parent call and then attach it to the metrics. The big difficulty comes how to propagate if your instrumented service then invokes another service, how to propagate the contacts to the child traces. This is very, very difficult because you need to work with pre-allocated memory. You need to also insert those traces for example, in a Go server, you need to insert this trace into a Go map, which is managed by the Go memory manager. So this becomes an unsafe operation because you could expose some data, and also because in the later version of the Linux kernel, you cannot write the user space memory. You cannot modify it unless you enable an unsafe kernel feature, but by default you won't be able. So this is something we're also working on. We did half the path, which is get the context from the parent, but translate it. Oh, sorry. Yeah, it's more complex.
Okay. Thank you so much for the talk, and yeah, I guess you're around for questions.
Thank you very much.
All right, so we'll continue with a talk from Monica, and Monica is from Cloudflare, and at this point it's almost tradition that we have a talk from Cloudflare every year here at PromCon, showing us all the newest and coolest things that they're doing with Prometheus and its ecosystem. So give it to Monica.
Thank you. Hello, everyone. I hope you all are having a great time at Prometheus conference. I am very excited to be here, and this is my first time attending Prometheus conference. Before we start, just a quick heads up. Most of my slides and the logos in it are hand-done by yours truly. Please pardon any imperfections or scribbles you may come across. So today I'm here to talk about what is alert analytics, why is it important, and how it can be done using open source tools. So hi, my name is Monica. I work as systems reliability engineer in observability team at Cloudflare from Singapore. Observability is to enhance insights into technology stack by gathering and analyzing a broader spectrum of data. In this talk, I'm going to talk about alert observability. This would look familiar to most of you. This is how a typical day for a lot of on-calls look like. On-calls receive a lot of alerts. Receiving too many alerts can lead to alert fatigue. Alert fatigue is essentially exhaustion caused by responding to unprioritized and unactionable alerts. Talking about on-call, I am on-call 24/7, 365 days a year, being a mom to a toddler. And talk to me about alert fatigue or toddler tantrums, I can talk about it all day long. It's 2 a.m., your kid wakes you up. Hey, wake up, I'm hungry. I generally suggest kid to drink some water and go back to sleep just to make sure he's really hungry and not dreaming that he's hungry. It does happen. Well, similarly, in case of alerts, we want to make sure that the alerts are accurate and not false positive. Receiving false positive alerts can make on-call person desensitized. So here are some general findings about health impacts of on-call work. Being on-call can lead to irregular sleep patterns, potentially leading to sleep deprivation. Irregular work hours associated with being on-call increases physical health risk. Being on-call can also impact social life and leisure activities, leading to decreased life satisfaction and increased psychological distress. The unpredictability and intensity of on-call work can lead to chronic stress, which can in turn contribute to burnout, depression, anxiety, and any other mental health issues. So let's look at how alert analytics can help reduce the burnout. Alert analysis is essentially reviewing alerts periodically and giving feedback to system to improve the quality of alerts. Have you ever wondered how many alerts your team is receiving? Which component or service is generating most alerts? Which is most noisy alert? Or which medium is receiving most number of alerts? Is it chat, PagerDuty, or ticketing system? How many alerts do not have it set up properly and are missing very important labels like priority, alert references, and dashboards? A very few companies and teams do alert analysis. This is a very basic information which every on-call should have access to, even managers. So who would this be useful for? An on-call person who would be able to see which all alerts fired during their shift so that they can draft their handover notes and not miss anything important. Managers to generate reports over time to see the improvement over a period of time. Managers to understand how the on-call is for the team and to see if the on-call person is vulnerable to burnout. Would also be interesting or useful for writing incident reports and to see if the alert fired during the incident or at what point the incident started. Let's first understand the alerting stack and how to get this visibility using open source tools. At Cloudflare, we use Prometheus heavily. We have point of presence in more than 285 number of cities, and each point of presence have their own Prometheus. We have over 1,000 Prometheus servers. All these Prometheus send alerts to Central Alert Manager. We have various integrations to route alerts, but we also route all the alerts to a single data store for alert analytics. So let's look at the life cycle of an alert in Prometheus. Prometheus collects metrics from configured targets at given intervals. evaluates regular or rule expressions, displays the result, and can trigger alert when the alerting conditions are met. For example, when we configure to alert when disk usage has reached 80%, it will be initially in inactive state. While it is evaluating whether the disk is full, it will be in pending state. And once evaluation is done, and if the alerting condition has met, it will be in the firing state. Once the alert goes in firing state, it will be sent to Alert Manager. On receiving the firing alert, depending on the config for the alert, Alert Manager can inhibit the alert. For example, if a server is down, there should be just one alert server down. It doesn't make sense to alert for 10 services down when the server itself has crashed. Second, Alert Manager can group alerts. If network partition occurs in a distributed system cluster, then instead of getting alert from all the instances in that cluster, Alert Manager can group the alerts based on group by conditions set in the config and send just one grouped alert. This way, alerts are concise and keep the noise level low. Alert Manager also provides a way to silence an alert during the maintenance or while the alert is being worked on. And it routes the alert to correct receiver integration, such as chat, PagerDuty, or ticketing system. Alert Manager, when configured properly, can mitigate most of the alert noise. But that is not the case all the time. We all know there will be alerts which are not configured properly or needs tweaking. So let's take a look at how to analyze if the alert needs tweaking. The alert in Alert Manager can be in either of these 4 states: firing, inhibited, silenced, or resolved. Alert Manager sends notification for firing and resolved alerts events via webhook integration. But Alert Manager doesn't provide notification for silenced or inhibited alerts via webhook integration. So alert reporting we were doing was kind of incomplete. However, Alert Manager API does provide capabilities to query. Webhook gives us firing and resolved alerts. Alert Manager API gives us all the alerts in active and suppressed or silenced state, and all the silences. Now the challenge was to merge this data coming from 2 different data sources and different format. So correlation of alert is done using fingerprint, as it is the common field in both the responses. Fingerprint is unique hash for the alert. It is basically hash of alerts label set. The Alert Manager API also provides us fields which are highlighted in green on the right, such as silenced by, inhibited by IDs, which is great. This would help us look up silence and inhibited alerts, which were not possible earlier. I decided to collect all the Alert Manager states data, firing, silence, inhibited, and resolved, using vector.dev instance and store it in a data store. Vector.dev, which is now acquired by Datadog, is an open source, high performance observability data pipeline. It is written in Rust and is vendor agnostic. Vector supports a huge range of sources to read data from and supports a lot of sinks for writing data to the destination data store. Vector also provides a lot of data transformation operations. So in short, we use vector.dev to collect data from sources, transform the data, and write it into a data store. Here we are using one HTTP server vector instance to receive Alert Manager webhook integration, 2 HTTP client sources to query alerts and silences API endpoints, and we are using 2 sinks for writing all the state logs in ClickHouse into alerts and silences tables. I have used ClickHouse for storing the data here, but any other database can be used. The reason I use ClickHouse is because ClickHouse provides a lot of data munging operations, like aggregating data while inserting using materialized view, or using replacing merge tree table engine to reduce the duplicates, or data rollups while querying the data. ClickHouse also supports join statement. Since we are writing data into 2 tables, we would have to use join statement to query data from 2 tables and visualize it. So if we were to create individual columns for all alert labels, the number of columns would grow exponentially with the addition of new alerts and unique labels. So we decided to create columns for only few very popular or very common labels like alert priority, instance, dashboard, alert references as individual columns which would help us analyze the data in general. And kept all other labels in a column as map of string. Because we wanted to keep all the labels in the data store with minimum resource usage and provide option to users to query specific label or filter out based on specific labels. For example, we can select all alert manager alerts using labels map service is equal to alert manager. The downside of using map of string is that lookup for map is comparatively slower than a string column lookup. But to be honest, I haven't really noticed big difference there. So we built multiple dashboards on top of this data, like alert name overview. This is drill down on a specific alert. Alerts overview to get insight of all the alerts alert manager is receiving. Alerts overview by receiver. This is similar to alerts overview, but specific to a team or receiver. Then alerts state timeline, which shows snapshot of alerts volume in a quick glance. Jira alerts overview. This to get insights into how many alerts are being sent to ticketing system, how many of these are firing or staying inactive or getting resolved. Silences overview to see silence stats, the number of active versus expired silences, how long the silences have been active, and the longest duration of silence. There were a few interesting finds. We found a few alerts which were firing and did not have notify labels set. So, which means the alerts were firing but were not being routed to any team, creating unnecessary load on alert manager. We also found a few components generating a lot of alerts, and when we dug up, it was for a cluster which was decommissioned and the alerts were not cleaned up. So these dashboards give us great visibility and cleanup opportunity. There were also a lot of stale silences where silence was created for a very long duration, in few cases up to few years, and were not relevant anymore. This is an overview of all alerts we receive from all Prometheus in Cloudflare. Like how many percentage of alerts are in firing, suppressed, or resolved state? Which region or instance is generating most number of alerts? And the alert volume over a period of time. We route alerts to team, or a team can have multiple services or components. This panel shows firing alert component count over time for a receiver. For example, the alerts are sent to observability team, who owns multiple components like logging, metrics, error, traces. So this panel would give alerting component count over time. This would give good idea about which component is noisy and at what time in a very quick glance. This is a snapshot of collapsed overview dashboard, alerts overview dashboard. This shows general stats and components and all the alert and receiver breakdowns. This also shows how many number of P1, P2 alerts have fired in last 1 day, 7 day, or 30 day. If the P1, P2 alerts or critical alerts are firing very often, then it should be reviewed. A few possible improvements could be implement alert inhibition, update the on-call priority to avoid overwhelming the on-call engineer. A good alert or properly configured alert should have clear information such as alert name, summary, priority, alert references, and dashboard for it to be actionable by on-call engineer. We created some panels in the dashboard to list the alert names which did not have these important labels. Silences. So when we silence alerts in Alert Manager, we can only provide matcher. And that matcher could be anything. It could be exact match or a regex. It could be alert name or any other label. The silence matcher doesn't translate to alert name or alerts count. With this analysis, we could see which all alerts got silenced with which silence ID by doing join operation, join query on the two tables, alerts and silences. We created this swim lane view using Grafana's state timeline panel for the receivers. This would give an idea about how busy the on-call was and at what point of time. Red here means the alert started firing. Yellow means the alert has been active. The green means it has been resolved. So here we can visually see when an alert started firing and how long it was in active state before it got resolved. Let's take a look at this dashboard. Can you see the problem? The highlighted alert is changing state too frequently from firing to resolved. This looks like a flapping alert. Flapping occurs when an alert changes its state too frequently, as shown here. It was firing, resolved. It could be because of alerts which are not configured properly and needs tweaking, like adjusting threshold or increasing the for duration period in the alerting rule. To avoid flapping alert, make sure to add a for duration field to alerting rule, which allows to add time tolerance before an alert starts firing. In other words, it means alert won't fire unless the condition has met for X minutes. This is another swim lane view with more number of alerts firing and with data rollups of to start of 15 minutes. So key takeaway for the stock are, make sure to use alert manager features like inhibition, inhibit alert, warning alerts by critical alerts, grouping. By default, all alerts for a given group are grouped together. A group by field can be specified to logically group alerts. Write recording rules to aggregate the metrics. Add a for duration field to alerting rule, which allows to add time tolerance before an alert starts firing. Make sure the alerts are actionable and have all the important labels for an alert to be actionable by an on-call engineer. Make use of annotations in Grafana to correlate the alert's volume with the incident or releases. Last but not the least, do alert analysis periodically and give feedback to system to improve the quality of alerts. The QR code is a link for a GitHub repo. It is a very basic demo for alert analytics. Running Docker Compose up spawns up a few containers like Prometheus, Alert Manager, Vector, ClickHouse, and Grafana. Vector.dev container queries Alert Manager Alert API and writes the data into ClickHouse. The Grafana has a dashboard, demo dashboard, which gives a few panels to give a brief idea about the alerts overview. And with that, I would be ready to take questions.
And before we hear the question, for all speakers, we forgot to give you your speaker gift, so you get yours on,
thank you.
on stage. But for all speakers who have already done their talk, please grab yours at the front desk.
Hello, thank you for presentation. My question is the following. So if I'm not mistaken, Prometheus already exposes all this information via time series called alerts or alerts for state. So what prevents you from doing the same analysis only based on these metrics in Prometheus?
But that won't give the silences or inhibited alerts.
Yeah, silences is the only thing which is missing, so probably Alert Manager can expose those. But otherwise, alerts can be analyzed in Prometheus itself, right?
It can be. So we were doing that earlier, not in the Prometheus alerts, but we were writing it into another data store with only webhook notifications, and we found few gaps. That's why we wanted to collect all of the states and then analyze the data there.
Okay, thank you.
Thank you very much. I found this very interesting. I'm curious, how do your teams integrate this into their operational practices? Like, how do they use this information?
In Cloudflare, not all the teams do this alert analysis. Only few teams were doing it earlier, and my aim was to offer this as a service so that it's easier for any on-call person to speak up about the burnout and the challenges they face. It's very easy to go with the data points. That was the main aim of this project. I hope that answered.
Okay, first I want to say thank you very much for the talk. It was really, all the talks so far were great, but yours was like perfect.
Oh, thank you.
I'm building something very, very similar where I work for. And it's very early stages. So what I've built is something that fetches alerts on PagerDuty API, aggregates per alert name, and just dump on Slack. Building something like what you've built sounds very complex, like to just build out of nowhere. So I'm interested in the life cycle, how this project came to be, if you know the history. How you started, what was the following steps, and when you got there.
Okay, so we've spent a lot of time in doing the similar work in past, and we were also looking at exporting data out of PagerDuty using the PagerDuty exporters, but the amount of metrics or the cardinality was way too high considering the number of teams and number of on-call person and the rotations. So it was getting very complicated to do that with PagerDuty, and we wanted to have it from all the systems, for instance, Chat, Jira, or PagerDuty. So I wanted it in not just PagerDuty specific, but in general, whatever alert manager is receiving from that perspective.
I have also another question, if it's fine.
Sure.
Are you open for collaborations in this project? I see it's open source, but I don't know if you are accepting contributions, maybe improve whatever you need to improve.
So this was done as a work in Cloudflare part of it, but I think it should be okay. Or probably I can sync up with you in detail because I don't know the terms and conditions. Yeah,
awesome.
Let's sync up offline.
So I think earlier in the presentation you talked about measuring burnout of folks on call. Like, is that something that you have a dashboard for as well? And then how is that computed?
So I actually wanted to do that. I wanted to build or come up with a burnout score kind of thing. Because when I started working on this, I was frustrated, to be honest. So this came out of frustration. And I wanted a burnout score, but the way Cloudflare works and the way our on-call rotations are set up, it was almost impossible to make it a generic. So few teams have 24/7 on-call, few teams have 8 hours, follow the sun rotation, and not every team member is in the same time zone. So it was almost impossible for me to come up with that, but that is something really good. I wanted to do that.
Thank you.
All right, no more questions? Then let's give Monica an extra applause for hand-drawn slides.
Thank you.
And we are going to have lunch now. Maybe some of you are hungry. Yeah, we'll have pasta, salad, and vegan curry in the room next door. So we are going to be back in an hour. Lightning talks, yes. I knew there was something. The lightning talks that have been submitted, I wrote down on the pen and paper at registration. You can see the order of the people who have been proposing something, and we still need up to 10 talks for just today. So if there are still slots, I mean, write them down anyway, because we have more today, tomorrow, but 4 more are possible for today even. So please submit lightning talks. Thank you. See you in an hour.
All right. We'll get started again. Hopefully everybody had a good lunch, enjoyed the weather outside a little bit. And now we've got David telling us how to make more efficient use of our Prometheus service.
So, hi everyone. I'm David. I'm a site reliability engineer, and my talk is finding useless and resource-hungry Prometheus metrics. So, I've decided afterwards that useless is a negative tone, so that's why the title is like that. Doesn't work. Okay. So to give a bit of context, so I have had this talk idea by I was recently given the task to fix a Prometheus setup. It was unstable. It has a lot of pod crashes, things like that, because it was running under Prometheus, under Kubernetes. It had many cardinality issues, and it was also using a lot of resources. So we had to do something about that. So this talk is divided into 3 parts. The first, we're going to see how we can use Mimir tool to analyze our Prometheus metrics. Then we're going to see how we can find and analyze hard cardinality metrics using Prometheus and Grafana. And finally, I will share a potential quick win to reduce even further the Prometheus resource usage. So let's start with analyzing our metrics with Mimir tool. So when I first had this task, I was asking myself, well, what's coming into the Prometheus instances? So I've had a look using this PromQL query to see all the metrics, the list of metrics that was here. But there was something missing. Like I didn't know what we were actually using and what we didn't. So I did a bit of research, and I've come to Mimir tool, which is a CLI tool that can be used to do various operations around Prometheus. Like the name implies, it's of course part of the Grafana Mimir project. So you have the documentation link if you want to learn more about the tool. But we're going to mainly focus on one part of the tool, which is the analyze part. So using Mimir tool analyze, you can analyze Grafana, rulers or Prometheus rules, and also Prometheus instances. So when you do that, so you will need to give it the address of your Prometheus instance and an API token, so a service account token now. And it will, if you do that, it will output basically a file which is named metrics in grafana.json, and it will include all the metrics sorted by, all the metrics that is actually used in your dashboards and panel and stuff like that. You can do the same thing for the Prometheus rules. So basically what it does, it would go through all your alerting rules and recording rules and do the same thing, like have a list of what's in there. And finally, when you test that against your Prometheus instance, it will grab the 2 previous files and compare them with what's actually inside Prometheus, and it will output a file named prometheusmetric.json, and it will actually have it separate which is actually used and which isn't. So metrics will, so the file look like that. On the left, I've shrinked it a little bit so it can fit in a slide. But basically on the right, you see an example of an entry. So basically here we have etcd request duration seconds bucket, where we can see the cardinality of the metrics and what job it's, and we can have that by job also. So why it's important to know that? Because when you know what you are using and what you are not, you can have 2 things. It can be an opportunity to monitor things that you were missing before. So you can have maybe new panels, new dashboards, new alerts. So there's going to be new stuff that you can have a look at. And it could also be an opportunity to clean some things up that you don't particularly need. So you can either remove it at the source, so configure your application on your exporter don't send it to Prometheus in the first place. Or you can, like, if you can't do that, you can use relabeling to do it. So it's always best to do it as close as possible to the source, because you will not get like network penalty, all of that. So for example, the Prometheus node exporter has a notion of collector. So you can enable or disable especially connectors. So for example, in this example, we disable the ARP and SOC stats. But if you don't want to disable everything, you can, like, either there is include and exclude paths that you can use on this exporter. Unfortunately, not all exporters will support that. So when it's not possible, you can still like decide to drop labels using relabeling rules. So for example, here we are just dropping the metric that we took in the exam before. So if you want to learn more about relabeling rules, you can have a look at the docs. And if you want more examples of the different configuration earlier, you can have a look in Kube Prometheus stack. The end chart has a lot of examples of things you can do. So there's still things to consider. So the metrics usage, so as we've just seen before, we compared our Prometheus rules and our Grafana dashboards against our Prometheus metrics, but maybe you are using your metrics elsewhere. So for example, if you have HPAs, maybe you are using a particular metric exclusively here that is not present anywhere else. So keep in mind that you will maybe need to import metrics you are using elsewhere if you want to have the list correct. And finally, the goal of this is not to drop everything that you are not using, especially since some metrics can be really useful during debug sessions and incidents. So choose wisely, and of course, focus on the ones that will with the highest cardinality. So now we're going to see how we can find high cardinality metrics with Prometheus and Grafana. So as you may have seen on the Prometheus UI, you have a TSDB status page where you will find a lot of resource, useful information about the TSDB, one of which is the top 10 series count by metric names, which is basically the metrics cardinality. And if you want to learn, like if you want to have more than the top 10, you can use PromQL to do so. And you can do, of course, for all the others. Just replace the number you'd like from this PromQL array, and you will have the list. So once you have the list of your biggest metrics, what you want to do is understand why they are big. And you have several ways to do it, but I found that there is a dashboard on the Grafana community, the dashboards that is really well made. And basically what it does, it allows you to basically see graphically the cardinality of your metrics directly in Grafana. So you have the dashboard link if you want to have a look. So I'll just do a quick demo of what we've just saw here. So yeah, okay. So okay. So my kind cluster should be up. Okay, so cluster is running. Good. Okay, so it's the other way around. Up. So what I'll start to do is expose my Grafana instance, so I can have a look, show you. So this is my Grafana instance. So what we need is to create a service account. So we'll add a service account. We'll call it Mimir tool, and we will give it the admin. I'm not sure if it's required, but I think so. We're going to create a service account token. Yeah. I'm going to copy that. And here. Okay. So we're going to save it here. So now that we have an API token, we can analyze our Grafana usage here. So what it did is it's created the metrics in Grafana like we saw in the slides. So as you can see, you have like all the list of metrics that I currently have in this Prometheus instance. And it will also tell you the one, like it would be also available by dashboard. So I don't, I'm running on Kubernetes and I don't have like flat rules files for flat Prometheus rule files. So I'm going to need to extract them. So I've made a really one command to do that. So I'm just, I now have like all my rules from my Kubernetes stack instance. Yeah. So yeah, recording rules, alerting rules, they're all glued together here. And now we're gonna analyze those rules. Like that, and it created a new file, which is metrics in ruler. And same thing, we have the list of everything that is available in our rules. And now that we have those two, we can expose our Prometheus instance, so we can test this against it. Yeah. So now I'll do Mimir to analyze Prometheus, like that. And it will output information, which is also included in the file. So if I have a look at metrics in Prometheus, it's Prometheus metrics, I think. Yeah. So now we have this file, which is basically what we saw. So we have in-use metrics counts, which is basically all the metrics that we use and sorted by cardinality. And we have the same things for, I think it's called other metric counts. So it's pretty easy to have the lists sorted, so you can easily see what you can use, what's used and what's not. So is it? Yeah. So I can show the Prometheus UI here. So as we saw earlier, so the TSDB status is here, and yeah, we can see like the top 10 of our like the 10 highest cardinality metrics of our Prometheus instance are here, but we don't know if they are actually in use or not. So we can, of course, compare that to the file we just created. But I know that this one is not used. So we're gonna pick this one to see how we can like try to understand what labels makes it big. So I'm gonna go back in Grafana. I'm gonna import the Cardinality Explorer dashboard. Okay. Taking a long time. Okay, here it is. So the dashboards has a pretty nice blocks where it explains everything about how it works at the top and at the bottom. So it's really easy to use once you've read the documentation. But just so you can see, I'm gonna copy paste my metric, and here is it. So here we can see that we have the metric cardinal that we just saw in the Prometheus UI, and here I have the information per label. So as we can see, so it's not loading completely well, but as we can see already, the type is what makes like the largest label from this metric. So, of course, we want to check how it looks like. So we can like compare that to the actual values, what's actually inside the metric. So if we look here, we see that the type is the resource. So yeah, obviously it's something that we probably want to keep. So the obvious thing is that we see that this label is huge, is big at least, but we probably need this information. It's probably the purpose of this metrics in the first place. So the second one is LE. So well, of course we are not going to even look at that because we probably infer that we want to keep that. And the last one is operation. So if we look at that, we see that the operation can be, so I can't read it from here, so we can have list with counts. Maybe we don't need that, like maybe this doesn't do anything for us. So maybe we think about removing this label and how would it affect the metrics series. So here it has a very good feature, this dashboard, is that you can check what would be the cardinality of that metrics without a particular label. So if I do that, so for example, if I try to remove the operation one, it will basically calculate that the cardinality would go from 7,000 to a little bit less than 4,000. So even if, like, as we see, like, it's not obvious that this label, like, it's not the biggest one, but it can have a huge impact on the final metrics cardinality. So if you have like high cardinality metrics, you can use these dashboards to basically like see what you can, if you can remove something to make your Prometheus instance behave, save resource and make it behave faster. So doing that, so doing that, I had pretty good results. So once I omitted the part where I've like really fixed the Prometheus instance from going out of memory. But after that, using this method, I've reduced my average CPU usage by 120% and average memory usage by up to 140%. So of course, this number would highly depend on where you're coming from. It could be a lot less or a lot more, depending on your setup. But if you never did this kind of exercise, I think you might find do interesting findings here. So last, to finish, I would like to finish on a potential quick win to reduce Prometheus resource usage. So you may have heard this morning during the What's New in the Prometheus land that there was a memory optimization using string labels that is now enabled by default after Prometheus 2.44. Actually, it will also reduce CPU usage. So it's if you haven't upgraded to this version or a newer one, you should consider, because it's free optimization down the road alongside all the enhancements that's part of the changelog. So that's mostly it. If you want to have a look at the output files of this talk, you can have a look at my github.dc/Prometheus Cardinality. You will have like the output files, and this talk is also based on 2 of my articles that I've written this year, which is the talk is basically a combination of the ideas shared in those 2. So if you have any questions, I'll be happy to answer them.
No questions. Are you sure? All right.
Hi, thank you for the presentation. I was just interested if you were also considering to expand potentially the Mimir tool to look at logs of the queries run in Thanos. You could potentially eliminate then the edge case when people just run a query in the Explore page, so it doesn't show in the dashboard, but they're querying some metrics that you might then delete.
Yeah, so we've discussed that. We didn't have to do it because we generally don't do that a lot, and when we do it, it's generally for incidents. So before dropping anything, we thought about like, even if we don't need these particular metrics, should we drop it? Is it taking a lot of resource, yes or no? If the answer is no, then we should keep it. So that's why you really need to ask that question on high cardinality metrics to see if you're going to keep them or drop them, because obviously you don't know what you're going to need in the future, and especially if you need that, you will have no history if you decided to drop it before. So you need to choose wisely. Okay.
All right, then another applause. Am I still doing moderation? All right, let's continue. So now we'll hear from Shopify about planet scale monitoring. Take it away.
So hello everyone. Welcome to our short presentation on the planet scale monitoring, handling billions of time series with Prometheus and Thanos. We are Sebastian and Miko, senior production engineers from Shopify observability metrics team, and we want to share our experience building a truly planet scale stack of metrics monitoring with you. So we recently migrated from a SaaS solution to in-house open source stack for metrics monitoring, and in this presentation we want to show the system and share the challenges we encountered on the way, learnings we had, and how we had to adapt the system to the scale we run at. So as we already introduced ourselves, let me take a moment and guide you through what we want to show you today. We will take you on a journey, how we built it internally in the first place, where we arrived with the solution at the end, with a few quirks and challenges we encountered on the way there, and how we tackled them for the benefit of company, but also wider community. We will also provide a bit of Shopify-specific context first, since the company profile presents few unique challenges to the whole system that we introduced here today. So now let me fill you in on a bit on the context of Shopify, unique challenges and infra choices, so Sebastian can present the actual system architecture for you. Shopify is one of the few biggest Ruby shops in the world, and the stack is deployed as a significant portion of the company infrastructure on Kubernetes. So some specific context why this company may have unique characteristics that may provide for a tough set of constraints for a system like this. It is very globally distributed. It's a global company with millions of merchants around the world, and believe me, there is some great research available on how latency affects conversion rates of buyers. So developers and merchants are very much interested in a consistently low latency to their shops. The scale of elasticity is a problem. Infrastructure is in motion all the time, very dynamically responding to the merchant demands, but also even during the periods of relative quiet, we are dealing with billions of active time series in the system. Hundreds of Kubernetes clusters are present, but we scale both in the number of them and how big they are. We very clearly see the ebb and flow of the day and night cycle in particular regions, but also specifically for our company profile, flash sales and big yearly events matter. So commerce happens all day, every day, but Black Friday or pre-Christmas sales are definitely noticeable in the grand scheme of things. Shopify is also the biggest flash seller in the world. So I mentioned the flash sale, so what it is? It's basically a merchandise drop that is very limited in quantity or time availability and presents a very unique challenge for monitoring and infrastructure scaling. So some flash sales are over in 5 minutes or less, and biggest of them sell hundreds of thousands, if not millions of items during that time. This presents a big problem to Kubernetes autoscaler, where with the very big clusters, it can barely respond in time to this immediate demand incurred when the floodgates open to the new drop. So this is a zero anchored graph on y-axis, and as you can see, even during a fairly normal week, we can easily see almost 100% scale-ups happening in the infrastructure over the day when it comes to number of monitored resources, in this case, containers. So additionally, something that may not be fully obvious to folks not working with Ruby day-to-day, or PHP or Python, it is not great at having facilities to share counters between multiple requests. So that results in additional challenges to efficiently utilize native Prometheus client libraries. On our way to sidestep this problem, we are using statsd for the Ruby portion of the apps in the infrastructure. But that's a whole other challenge in itself. How do you push this and not pull into a Prometheus infrastructure? Which my colleagues, Pedro and Philip, will gladly explain in tomorrow's first presentation. Now I'll hand over to Sebastian to dive a bit deeper into the architecture of the specific system components.
Thanks, Miko, for the introduction. I'm Sebastian, and I will guide you through the components or through the architecture from a metrics collection to querying. Now, I will introduce you to the architecture of the system we built that monitors Shopify infrastructure, but also all the applications that run inside Shopify. and also show how we address the challenges Miko was just talking about. Yeah, like as I said, we first look at the single components, and at the end we will fit this together to a big picture. So let's start with in-cluster metrics collection. In Shopify, we have hundreds of clusters with thousands of very different workloads. And as targets or metric sources, we have roughly those types: natively instrumented workloads or exporters that get metrics in from external services that can directly be scraped. Also infrastructure metrics exporters like CubeState metrics, node exporters, or CAdvisor, and so on. And we call metrics coming from those internally standard metrics because we deploy them in each cluster and they are available for every workload and every cluster. And then Miko just hinted at this. We have the stats-d metrics coming from workloads. Like, I won't go any deeper here because, again, tomorrow is this other talk where Pedro and Philip will give a deeper insight on this. We have the stats-d pipeline. Essentially, you just write stats-d into it, and then we aggregate, and it's becoming scrapable by Prometheus. Yeah, so when we initially started, like our first deployment for this was Prometheus agents plus HPA, and for the target distribution over Prometheus agents, we used the standard hash mod. This wasn't working for several reasons. The first was while the number of targets for each Prometheus agent was nearly evenly distributed, the problem was that the sizes of the targets was vastly different. So while some agents were idling, other agents were ooming. Then if you scale up, or if HPA scales up the Prometheus agents, like adding more agents, we had this problem with redistribution of targets, so there's a lot of movement. And also HPA itself, we used memory, and we used memory and CPU. The scale-up was slow. So what we did is we implemented this custom operator, and it works as follows. So what it does is we have the service discovery part, which is the service discovery part from Prometheus. It gets a standard Prometheus config, discovers all the targets in the cluster, and then writes those targets in a queue where workers take those targets, scrape them once, create a report. The most important information in the report is just the target size, put it back into and send it back to service discovery. And then what service discovery does, it scales the Prometheus agents accordingly and creates configuration for the Prometheus agents so that the distribution of the load over the Prometheus agents is even. Yeah. So and this worked. And yeah, Prometheus agents just they have standard configuration, then they scrape, and then they remote write in what we call regional receivers. In Shopify, we have multiple big regions, and we decided to have one receiver deployment. I will explain the deployment shortly. We have one. In Shopify, we have those regions, and we have one deployment per region. Why do we do this? First, no single point of failure. So if one region goes down, other regions still keep working. We can use internal regional networking for remote write because all the client clusters are in the same network, and low ingestion latency and overall less networking issues. And also, we don't need to pay for egress and ingress traffic. So the first deployment was just standard receivers, so just multiple receiver instances. But we had several issues there. The most important issue was it wasn't really stable during rollout or when one receiver went down, because a receiver has then both the role of forwarding and ingesting metrics. So what we did is we split up the routers to solve this problem. We split up into routers and receivers to solve this problem. So only the routers need to know where metrics go, and receivers will ingest metrics, but also upload blocks every 2 hours into an object store for further processing. Then there's this concept of tenants for in Thanos, and we what we do is we have one tenant per cluster, and this configuration or the hash ring is created by Thanos shard manager, which is kind of operator for routers. And what it does, it looks into our global view for our infrastructure, and if a cluster is added or a cluster is removed, it creates a tenant, and then this tenant is a CRD, and according to the CRDs, it will then configure, create a hash ring. So yeah, I forgot to mention this, we have replication factor 3, so it will at least add like 3 nodes to each, for each tenant, but you can also have more nodes. Because our clusters have different sizes, so for big clusters, you maybe want to spread a tenant over like 6 or more nodes. And that's what the shard manager does, because he has, the shard manager has all the information. Yes. We also have the possibility if a cluster grows, which happens often, to rebalance or grow tenants by running a simple command. Yeah, and those metrics from all the regions, so we have multiple of those regional receivers over the world, can be queried via query deployment in front of receivers. But before we look at querying, let's have a look at how we handle long-term store, like the blocks that are uploaded to the object store. They are first horizontally and then vertically compacted. Other way around, sorry. And also downsampled. And then we have stores, like 2 sets of stores. One set of stores is responsible for everything until 4 weeks. And this is much beefier than the stores that handle everything from 4 to 12 weeks, because most of the queries that are run are below 12 weeks. Yeah, and in front of that, again, we have a set of queries, and this lives only in one region, and it will be queried. It can be queried via the queries. So, yeah, so now how do we use those metrics to run rules, alerting, and query? Let's start with rules and alerting. Rules and alerts are evaluated by running global queries against all regional queries. So there will be an overview coming. And yeah, we have they send alerts to alert manager, and alert manager can send them to Slack on PagerDuty. Miko will show you in the next slides how the configuration of that works. Rulers are just, also query the receivers, the regional receivers, and write the result of the rule evaluation into another set of receivers, which work as the regional receivers. It uploads block to object store, but it can also be queried by the user directly, which we see here. We call this the global querier. The global querier is a set of queries that query the regional receivers, that queries long-term storage, and that queries results, rule results from the rule receiver. Sorry. And for caching, we have a query front end in front of the queriers. And the metrics, everything can be queried via a Grafana instance, which is customized via plugins. And Miko will now tell you how this works.
Yep, so far, Sebastian explained to us how this actually works on the backend. So what does the system power? Grafana, naturally, but with a few customizations created specifically for our developers in the form of custom plugins. So what are the twists that are present in our setup? For example, new metric list, detail views of metrics, which I will show you in the next part. But for example here, alert configuration. Since Shopify is a pretty big organization with hundreds of teams, we decided to enhance the standard UI. We are exposing more team and service-centric UI for our developers, making sure that they can always find relevant information as the first step in the investigation that they are going through in the alert case. Since we are talking about metrics, we focus on that, but you can also see that we directly link this information to other internal tools, so that it makes it very easy to follow different observability signals relevant to the service straight from this specific UI. We also had to enhance the custom SLOs. So setting up a service in our company requires creating SLOs for them, and we also had to bend Grafana a bit to allow our users to track this performance over time. As you can see, it relatively closely follows the idea set up in the previous slide of custom alerting. Same problem applies here, where many teams want to only be presented with their own specific service-centric views, so that's what we decided to focus on. So, as can be understood, this system is pretty new. There was a migration. This is only a few years in the making compared to over a decade of Shopify. So migration happened, and we faced a few challenges on the way. As you already heard from Sebastian, most of it is related to proper deployment patterns, but not everything was possible to be fixed that way, and we either had to develop new pieces in the stack ourselves or contribute back to community where we faced the challenges that were also relevant to them. Last year, my colleague Philip presented on this conference earlier version of Thanos distributed query engine, which unlocked for us internally, but also for the wider community, since it's fully open sourced and used in Thanos, ability to query multiple times faster across very large queries, happening over multiple queries or query layers. This is what Sebastian explained as pushing down the computation as close to the source as possible. Most importantly, we also got involved into a native histogram work, which internally solved some cardinality challenges for us and proved to be another factor in reducing operational costs, and in tandem with the distributed query engine enabled us to provide simple global alerting across hundreds of very dynamically scaled clusters. But what I'm showing you right now is something different. It's a fast metadata series querying. It's a view of this. We had built it on our own metadata querying to power a few components. Fast metric search, which is especially useful in powering very easy to use visual query builder. Developers love to know ahead of time which, with instant response times, what are the all possible value combinations of all the labels for the metrics, as you can see on the left side. Metric cost components, which you can imagine help us to get some more buy-in from the teams regarding the quality of data they produce and how this contrasts to the cost of actually storing them. And most importantly, referenced in, which can be seen on the right side of this slide. I think this closely relates to the topic of previous talk. This helps to very quickly reference all the places that a specific metric is used. You can see like dashboards, alert tools, SLOs, very easy to find. Where is it used? But most importantly, if it's used at all. So fast metadata querying is very important at our scale because native experience with our amount of metrics was unfortunately a little bit lackluster because of lack of pagination of results. That same system we hope can also help us more with cardinality control over time. But technology is hard, but sometimes the hardest challenges are human in nature. Migration prompted us to work very closely with app developers to build even more observability or visibility tools in Grafana. Let me give you one counterintuitive example how we decided to migrate between two very different metric monitoring systems. We actually decided to not migrate metric dashboards from the previous vendor to our in-house solution. Instead, we work very closely with developers to create new dashboards, only inspiring themselves with what they already had. It was a very tireless work, but resulted in a better quality dashboards, suiting better the needs of developers, created with this new system in mind already, while allowing us to leave the legacy dashboards behind, evaluating what was truly needed at this specific point in time. So now onto the final view of the system with Sebastian.
Yeah, to wrap this talk up, I want to put this together and show you one picture. You see like our globally distributed regions here, like the placement of the regions doesn't have any meaning, it's just random. And as you can see again, we have the global queryers querying everything, and like users can do this via our Grafana deployment, then rules and alerting, also using like querying everything from the regions. One thing that, like Miko just showed us, the UI is driven by so-called monitoring API. What it does, it takes in alerts and SLOs from the UI and creates the rules and alert config for rules and alerting. But it also extracts metadata from long-term store by going through all the blocks there, extracting the metrics names and labels, and providing this to the Grafana in the Grafana UI, as Miko just showed you, so users can look into this. Yeah, and one thing I forgot to mention is this distributed engine. Miko mentioned this briefly. This thing was really important for us because it allowed us to essentially to query over our whole data set. With the Prometheus engine, the issue we had was that if you run a query over the whole data set, it first gets all the series, bubbles them up in the top-level query, and alone the amount of data we had there was too much sometimes, so yeah, the experience wasn't really good. And with the distributed engine, what happens is the work is pushed down, it's evaluated at the lowest level possible, and only the result is bubbled up and aggregated there. Yeah, so that's it. Any questions?
We actually have a decent amount of time for questions because I made you start a little bit early. Sorry about that.
Hello. Hey. So I would like to ask, are you using persistence for the receiver? And also, how much time did you invest in caching? I mean caching for like store gateway.
Can I answer? So we don't use persistence for receivers. Yeah, because this, and like, I mean, like, you have those 2-hour blocks, right, and you upload them directly into, so like if something goes wrong, like if everything goes wrong, you maximally lose those 2 hours. And caching, we just put the front, we put the query front end on top of it, on top of the queries. We had to add native histogram support and configuration, like trying what works for us, because it's like this time where you don't cache, like you have to find the right, I think it's 10 minutes, the first 10 minutes.
Yes, maybe just giving a little bit more context here. We use Prometheus in an agent mode very early in the system, in the regionals, so that does not have a persistence, but later on, when you already bubble it up to the big regions that are cardinal regions in our case, that's where we have some disks. But obviously the most important part is using the LTS Thanos storage.
But the receiver is no storage. That's the, if it dies, it just
yeah, we
comes
don't
up.
really use this as storage. It's only like, I believe only in memory queries for a couple of hours in our case.
Okay, thank you.
Hi, I'd like to ask, you mentioned that you do basically an initial scrape to size the agent, and basically size is based off the first scrape. Did you then run into any issues where the initial scrape wasn't too big, but the number of metrics grew over time and potentially caused
You mean the
kills?
initial setup without our operator?
No, like with the operator you mentioned, there's the initial scrape that sizes the agent.
I mean, no, how it does it, it runs in a loop. And I think every 5 minutes it checks the targets again. So every target is scraped every 5 minutes. The reports are their new reports, and then if something changed, it will scale up and redistribute targets to agents if possible, if necessary.
Hi, I got a question from the live stream. How do you shard rules?
How do we shard rules?
Well, actually, as Sebastian mentioned, we use cluster to tenant mappings. So we try to, as much as possible, have rules sharded by a cluster or tenant, right? That would be perfect. If you don't go the very high scale route, this is good enough. If you go really high scale, definitely go for native histograms, as Sebastian mentioned. That helped us a lot, and we actually are able to run fully global rules thanks to that and thanks to the distributed query engine. That changes the game for us completely. Like, it was impossible without those two fixes upstream, and now that this is in the upstream, it changed the game for us. Hundreds of Kubernetes clusters, all the global rules, no problem.
Thanks.
Did you consider like splitting like the data storage per environment, like for Thanos? We had like a case where we have a mix of data like across environments, and we have somehow like we mixed it up with dev environments, and then like Thanos frontend like went crazy a little bit, and we had to clean up the data. So we have to go through the object store and so on. Then we came up with this idea to split Thanos storage per environment.
I mean, you mean like the stores I showed you? Are you talking about the long-term stores?
Yes, exactly.
Like they are sharded. So like we have multiple, like, as I showed you when we go back to this slide, you see this is not just one instance. Like we have multiple instances, and they shard per tenant.
Okay, thank you.
So there's not just one store owning everything. There's multiple stores running owning several tenants.
Other than that, that's why we even have a regional layer of this. In case of one region getting corrupted, we
but
also
not for
have
long-term storage.
additional, not for long-term storage, but before that. We tend to find all the issues with the data before it ever reaches the very long-term storage.
All right, thanks.
You said that you were using native histograms?
Yes.
And you're in Ruby. However, the native histogram are not part of the Prometheus Ruby client yet. So are you able to use it through the stats.d instrumentation you have, or do you use
essentially, we had to add this native histogram support to every part. So there are, I think there are even some PRs up now. I'm not sure, but
I think it's already merged.
It's like for stats.d it should be merged. I'm not sure because I'm not working on this. For Thanos, there are some PRs, but this is experimental, right? So,
but if you are looking for some experiment at scale, this works pretty rock solid. This actually improves the stability of the system.
Okay, thanks.
Hello. How you mentioned that you use query for global querying view, which queries all the store gateways and all the receivers, as I understood. And my question is, how many receivers do you have, and whether this query works stable for a big number of receivers?
I can't give specific numbers, but let's say hundreds of, and not at the lower end of 100.
So your query sends a query simultaneously to 100 receivers and gives...
I mean, I talked about this. This is why we need the distributed engine, right? Because if you fan out to so many receivers, a lot of data come back. And imagine having multiple of this, so much more data comes back. And if you try to evaluate this in one place, you will have too much data.
That's one thing. Then remember the Bloom filters. You actually only query the relevant data in the end, right? You query a lot of endpoints, but most of the endpoints are irrelevant for the query to answer, right?
Oh, I see. Thanks.
Just one question. You're pushing the data to the Thanos receivers in routing mode, and then again to the receivers. Are the receivers dedicated to specific clusters or customers, or are they shared?
So if we go back to the slide, you see here the Thanos shard manager creating this hash ring. And so we try to assign tenants, and tenant is a cluster, to routers, to receivers in such a way that the load is evenly distributed, right? Because big cluster needs more in-memory series And we can rebalance this. So if it changes, we can run a command to shift.
But this is basically why we even have this component, to be able to like pin and easily move specific TSDBs for specific tenants, or in our case, clusters, right?
Thank you.
All right, last question over here.
It's so late.
Thanks for the talk. You mentioned Bloom filters and not querying all regions, all clusters for a query. Can you give more details about that? Like, how do you know when I send a query, where to go search for the results?
I mean, queries go to every receiver. Always to everything. I mean, we have some restrictions per time. So like 6 hour, all queries below 6 hours don't, or 2 hours, I don't know, go to stores, but otherwise they go to everything. But like it's a no-op response, right? So if it doesn't have data for this query, like nothing comes back.
Or if you prefer, you can obviously filter by specific tenant, then it will go only to that specific receivers that are assigned to that tenant, right? But we found out that most developers just don't bother with scoping the, it would be perfect world where everyone was just scoping their queries very nicely, but if they don't, we actually are very happy with the performance of the fan out and comeback with like most of the empty responses.
All right, that's it. That's all the time we have. Another applause. All right, without further ado, now we'll hear another talk from Grafana Labs.
Hello. Today we will be talking about using green metrics to monitor your infrastructure's carbon footprint. So my name is Ida. For the last 2.5 years, I've been working for Grafana Labs as a software engineer. My passions are promoting the gender diversity in tech, and I'm trying to be an advocate for that.
And hi, I'm Nikki. I'm also a software engineer at Grafana. I'm also a CNCF environmental sustainability tag contributor, co-chair of the Green Reviews working group. The tag ENV has been in place since a bit over a year now, and our focus is advocating for green IT in the cloud-native ecosystem.
So, since Nikki joined Grafana, she has been a great advocate, and she has been promoting the topics of green metrics and sustainability in cloud. And she got us together with Leonor, Sophia, Adam, and myself, and other great folks that are not on this slide, to join a hackathon project that was deploying Kepler in our dev cluster. And that's how this talk came about. So today we will be talking about environmental sustainability and cloud computing. We will be focusing not on actually how to reduce carbon emissions, or we won't be giving advice, but the first step to reduce your emission is actually know how much you're emitting. So on this picture from Climatique, you can see that the share of global CO2 emissions for data centers are in the range between 2.5% and 3.7%, which is quite a big range. It's in front of aviation, shipping, and rice cultivation, and other sectors. For me, what was the shocking thing on this picture is that data centers are actually emitting more CO2 than aviation. I think that's quite high. And also, the range is pretty big. If you think about it as the share of global CO2 emissions, I think this picture shows us that there is still, it's not easy to collect data on emissions in the data centers, and also that we don't know, we don't have the information of actually how much we are emitting exactly. So why to implement green ops for your company or your business? I think the term net zero became a buzzword by 2050. I actually didn't even know what it means. I don't know if you do. But it means actually 90% reducing your emissions and 10% neutralizing. So it's a pretty big commitment. I think the term was coined during the Paris Agreement talks. And many, even very known corporations are committing to net zero by 2050, which is actually a quite tough thing to meet, but still we have some time. Another good reason is saving costs. So sometimes when we reduce our resource usage, we also reduce costs. For instance, getting rid of zombie clusters, zombie pods, we're saving some costs, some energy. Another great thing to do is optimizing your app performance, or in general performance. So if your app is more efficient, you're saving energy, you're implementing green ops. Another thing is product differentiation. So your company can do something else, what the competitor is not doing. It's great for marketing, for investors to see that you work for a green company, also for customers that they feel better about using your product, and also for maybe potential employees whose values are aligning with your company's values, green values, so to say. Yeah, governments all over the world are coming up slowly with some regulations about compliance on sustainability. For instance, the EU, actually the EU Council, came up with the Corporate Sustainability Reporting Directive, which says that the publicly traded companies will be required to report their carbon emissions for the 2024 financial year by year 2025. So still not that much time. And also the US SEC is debating the climate disclosure rule, which also makes the companies show the investors how great would they tackle the climate crisis and how their business model will survive the emerging climate crisis. So there are categories for emissions. Scope 1. Scope 1 are direct emissions. So for instance, you're driving your car, you're burning fuel, Scope 1 emissions. Scope 2, it's you're using your laptop, it's plugged into electricity, Scope 2 emissions. If you're using your laptop, the hardware was produced and used up some energy, Scope 3 emissions. What does it mean for cloud? I mean, in cloud, we don't care about Scope 1. That's not something that is included. But we care about indirect emissions. And for instance, the electricity used in private cloud, that's Scope 2 emissions. Scope 3 emissions is electricity used in public cloud, for instance. This picture shows that the Scope 3 makes a much bigger share of emissions in global emissions from the cloud users. That does not mean that the public cloud is actually less sustainable or emits more carbon footprint. It only means that that's the thing we need to focus on, to reduce. Actually, the opposite is usually true, that the private cloud is actually less sustainable than the public, but Nikki will talk more on that.
Yeah, so let's talk about cloud-native energy and carbon monitoring. So AWS has shared this diagram about the responsibility of customers versus AWS in the cloud. So AWS is responsible for the sustainability of the cloud itself. That means cooling, which is one of the most energy-intensive parts, and electricity supply, for example, ensuring that the supply is from green or renewable sources, or carbon offsetting is a strategy that is used a lot by the hyperscalers, whereas customers are responsible for sustainability in the cloud. That includes application design, and that includes auto-scaling, for example, and that also includes scheduling. For example, if you schedule certain batch jobs that are not time-sensitive in regions that are using less, that are less carbon-intensive. So there are ways to do this. That's called carbon-aware scheduling. So the problem is that we don't have granular data on the energy and carbon emissions of our cloud-native software. And so this, for example, is a screenshot of AWS's customer carbon footprint tool, which is useful for long-term carbon accounting, but not for engineers. There is a 3-month data lag, so when the EC2 instance uses the electricity, you get the emission in this dashboard 3 months later. So this is the issue of top-down versus bottom-up energy and carbon accounting. Moving on to Kepler, which is an energy monitoring tool that exports to Prometheus. So what is Kepler? It's a Kubernetes-based efficient power level exporter. It was created by Red Hat/IBM, and it was recently donated to the CNCF. It's a sandbox project. How does it do energy monitoring? The first step, it aggregates the energy metrics. So it uses either RAPL or an estimation model. RAPL is an Intel technology that aggregates energy metrics from the processor and exposes those metrics. And there is an issue, of course, in the virtual machine environments. You don't have access to RAPL because of the hypervisor. So in AWS, the RAPL is not available. Even in some bare metal EC2 instances, RAPL is not available. There is a workaround for this. If RAPL is not accessible, Kepler falls back to an estimation model. So this is actually trained data on different types of compute through a machine learning model. There are issues with that as well, but that is, there's already a pre-trained model that's done, and so you just use the data from it, and so that's the estimation model. Then it uses eBPF to attribute power to process to pods. So eBPF will look at the energy metrics and associate those with the C group ID and the container and pod that are matching. And so that way you can have pod level energy metrics as well as node level energy metrics, and you can use then Prometheus to query for the namespace, for example. And yeah, it exports the metrics to Prometheus. Some issues that I mentioned: there's no access to RAPL in VMs. There's also some security issues. If you have energy data that is like less than 50 seconds interval, then you have you may be liable to the what is called the platypus attack. So this is a fun fact. It's very interesting. What it is that you can infer cryptographic keys based on the energy consumption by it. So you need to increase the intervals to avoid this to, I think, 15 seconds. And eBPF, well, with Kepler, we had to read the kernel header files. So in some AMIs, the kernel header files are not installed by default. Some in GCP, I believe, are, but on the ones that we were using, they weren't. So we had to do this manually in ways that I am not allowed to say. Maybe it involves some sudo. But, So it was a dev cluster, but it doesn't scale, so that's the issue if we want to move from dev to prod. There are issues that we need to tackle. So now we're going to look at some panels and queries. So this one is the carbon emissions in our cluster running in US East 2. We looked at 3 nodes. So we used a node label selector to just target the nodes that we wanted in the namespace that we wanted. And what we're doing in this query is first see the Kepler container joules total that aggregates GPU, CPU, memory, and other like energy processes that we just talked about, the whole other setup. And we're looking at the namespace hosted Grafana. We used a hard-coded variable for the watts per second to kilowatt hour. This is a standard conversion of energy metrics. So this one is, that's a set hard-coded metric. Another hard-coded variable in this case is the carbon coefficient, which I'll talk about in a minute. In the first part of the query, we're getting the kilowatt hour, so the Kepler metric with the kilowatt hour multiplications of the conversion. So we get that per hour. In the second part, that can be improved. We are trying to get the hours of samples. There are issues if there are certain hours with no samples. There would be an issue with this query. So we welcome you to propose enhancements and improvements as well. There are definitely other ways to do this, but this is what we're working with. And so, yeah, we get the CO2 grams per kilowatt hour per day. The carbon emission data, like we said, we use some carbon coefficients. These are, the sources are various energy agencies. We did look at the Cloud Carbon Footprint tool, which I believe is maintained mainly by ThoughtWorks, and they have hard-coded this data. Ideally, we would use live carbon emission data. For example, there's WattTime API and Electricity Maps that are doing fantastic work. I think Electricity Maps works with Google as well for carbon-aware scheduling.
So yeah, there's another panel that we thought could be useful, maybe, if you decide to implement Kepler, which is power consumption per pod or tenant ID. If you decide to implement Kepler on your clusters, this could be great to show your customers that they would know how much power consumption their application has, or for engineering teams to know, like between releases, if the power consumption changes, if it increases, decreases, if new features are enabled, if something happens to the power consumption. Also for platform teams to see which namespaces are, how much power they're using. So I think there are many stakeholders that could benefit from this one panel. We also built some other panels just for fun to see the total power consumption on the cluster for the namespace in an hour or for a week, and also throughout the day, how the power consumption goes up and down.
So what's next? There are some other use cases that we're looking at. So for example, in the Green Reviews Working Group, we're currently using infrastructure that was donated by Equinix to the CNCF. It's called the Community Cluster, and we're now building a pipeline with Cluster API and Prometheus, Grafana, Kepler, so that we can measure the energy consumption of various CNCF projects. We're starting with Falco, which is a security tool. So what we're going to do is we're going to look at various scenarios and also like idle scenarios, various reconciliations, and see how it performs. So we're essentially doing some benchmark tests, maybe use case 6, not sure yet. And we're going to then use the metrics from Prometheus in dev stats. So that's like it's actually a Grafana dashboard, which is used by the CNCF to look at to track various CNCF projects. And so we're going to track things. It's actually replicated from the tag securities, security assessment, review process, something like that, where they have contributors assessing the security profile of different CNCF projects. So actually, security and sustainability have a somewhat similar operating model in some ways. Other things we're looking at is how to move from dev to prod. I mean, there's a lot of challenging tech with RAPL and eBPF, and the security issues that we mentioned, but we're moving this along. And yeah, and we want to see also, can we use this to inform decision-making about infrastructure provisioning? Can we inform the metrics that we export? Can we do some scheduling to deploy pods to nodes? For example, there's a study, and I don't have the source of my mind, but that for servers to optimize their energy efficiency for cooling, the ideal usage would be like 60 to 90. I mean, it's 70 to 90, there's different numbers, but some could use this data to schedule according to this optimization. So, and also, I forgot to mention that the Green Reviews Working Group, we're going to implement this in the build lifecycle. So when there's a new release, we want to measure the energy consumption and see, did it change? Any feature that was added that changed this, etc., and give recommendations around this. So thank you for your attention. We have the CNCF Slack channel, Tag Environmental Sustainability. You're very welcome to join and contribute. We have regular meetings that are open to everyone, and happy to talk about this more. And yeah, thank you. Yeah. Are there any questions? Yep.
Thank you for the informative talk. I know that there are some data centers that are boasting that they diversify their electricity. For example, they use more green energy. Do you know if tools like Kepler, for example, can export metrics, and maybe we can use them for scheduling?
So, in which context?
Yeah, that was just my idea, but first of all, the question is, do you know if I can find this information as a metric in for example, Kepler?
Of the data center itself, or your?
Yeah, the public cloud data centers, because, for example, in Google Cloud, you have this green icon which shows you that this is like a green location.
Yeah, that's a great question. So yeah, GCP does have like a little leaf next to the regions that are powered by renewables. AWS has a list of the regions that are powered by renewables. They also use carbon offsetting, so it's not always green. Anyway, it's fine. I'm going too much in details.
You can Google, for AWS, you can Google, there's a list of data centers that are running on renewable energy.
And what's also interesting is that the Green Software Foundation, which is under the Linux Foundation as well, is working with, they're trying to work with cloud providers to provide the metrics that we just talked about here using Kepler. So maybe this will, in 2 years, we'll have this as a offering, but it's very, very difficult. The reason, for example, that there's a data lag in the customer carbon footprint tool that AWS has is for security reasons and legal reasons. It's very difficult to provide that kind of data from the data center itself, of course. Yeah. Yeah.
I have a more general question regarding green energy. As I understood, the green energy is produced by wind turbines and solar panels, yeah? And probably wave stations which
hydro
generate energy from waves. And the question is, according to graphs, energy produced in graphs, this green energy sources produce most energy in waves, daily waves. During there are some periods of times when the green energy production is very low, and it cannot cover the demand of this energy. And my question is whether nuclear energy considered as green energy or not.
So nuclear is clean energy in terms of terminology. So that's, I've been saying renewable and green or clean energy to include that. Now this is a question of ethics that is beyond, you know, this presentation.
But I mean, nuclear is not considered renewable,
No.
but even though it emits much less.
It's clean energy. This is the terminology. Don't shoot the messenger.
Hi. You mentioned briefly using this as input for scheduling of like batch jobs and stuff like that. I'm up here.
Ah, yes.
Are you aware of any projects that use like basically integrate this sort of scheduling with like smart grid inputs, you know, when power is available, run batch jobs, this sort of thing?
Absolutely. So KEDA introduced a carbon-aware scheduling feature. So KEDA is one. KEDA, you know, full disclosure, is primarily there's a lot of maintainership from Microsoft, and so KEDA definitely does, and we do have some KEDA maintainers who come to tag and meetings, and you know have worked with the tag to some capacity. And Carpenter, which was primarily was created through AWS, there is recently there's an issue open to implement that kind of scheduling logic, like carbon-aware scheduling in Carpenter as well. And there's other tools as well. Actually, the tag, we have a landscape document that we put together I think almost a year ago, and it's a white paper with a lot of different tools. So if you go on the tag environmental sustainability repository or the website, you'll find this document with more tools.
So you mentioned that you get the energy consumption from Intel RAPL. Like, are there alternatives for like ARM CPUs, AMD CPUs, and if it falls back to the model, is that like a generic model that you can apply to the CPUs from all the vendors, or like how does that work?
Yeah, it falls back to the estimation model if RAPL is not accessible. When it comes to Kepler, I don't know of another tool that can. Well, there's Scafandre, which is a tool that also does energy monitoring, and it's also used in a cloud-native context. I'm less familiar with it, but I don't think they've solved this issue either. Great.
There's a
there's
question
one
up
more
here.
question. Okay.
Yeah, so it's just a question on Kepler, but rather if you know the existing tool like KubeBench, for example, but for this purpose, like maybe a tool that will recommend me that I should be running my workloads in a particular region, or maybe use maybe more IRM instances rather than x86, things like that, that would help me reduce my footprint.
Ooh, for like specific recommendations of things to change, that's a really great question. I mean, definitely there's some auto-scaling, I would say, and Carpenter, I think, have been the tools that I've heard of that have helped the most in FinOps, in applying FinOps. So if you can implement that kind of smart scaling, then, and if you're aiming to reduce your cost in a FinOps way, then you kind of may reduce some of the carbon and energy consumed by your infrastructure. So FinOps practices and techniques and patterns are often recommended for like the specific things. It also depends what you're optimizing for, because sometimes if you're optimizing for cost, you're not necessarily reducing carbon. Like if you're going from a region that is cheaper, with cheaper offerings, it's not necessarily related to carbon. In the same way, if you're optimizing for carbon, you might be actually the time spent implementing those solutions might cost more. So there's also the Green Software Foundation, which has patterns recommended, and again, the TAG sustainability website might offer more specific solutions.
Thank you.
All right, that's all we have time for. You, of course, also get your speaker gifts. Here you go.
Oh, thank you.
Now we have another break, which I forget for how long. We have another break for 30 minutes, and we're back here at 3:15. So we've got a couple of snacks again.
understood that? Can you just talk?
Okay, I don't know what I'm talking about, but
Okay. Let's start over. The break was super nice. I got really good vibes, but I'm happy so many of you came back in. We have a good few talks lined up for the rest of the day, so this is the last kind of part of today, and then we'll head over to the social event after that. But for now, I'm super, super excited to learn something about monitoring 3D printers, and I've been looking forward to this talk, so I'm pleased to welcome Pavel to the stage, and go ahead.
Okay, hello, I'm glad to see you there. This is my second PromCon. I was first PromCon was in Munich last year. And I'm here to tell you how we observe not only world's most famous 3D print farm, but also how we use Prometheus at Prusa Research. Yeah. Who am I? My name is Pavel Strobel, and I am DevOps engineer at Prusa Research. Next, I am also a Cloud Native Prague organizer. We are organizing meetups about Cloud Native technologies. My main topic is SRE and observability. I sometimes do something about infrastructure here and there, but that's not main thing I would like to do, so I'm more a SRE and observability guy. Besides that, I also like to homebrew my beer. And did you know that you can observe a process of fermentation of beer with Prometheus and Grafana? And I play a lot with hardware and IoT. 3D printers are my thing. I like messing with my cars and something like that. So, how do we use Prometheus? If you think about Prusa Research, you'll think, okay, these guys made 3D printers. But it's not only that, because we run multiple web services, for example, printables or eShop. And we need to monitor somehow these services. That's why we use Prometheus. This is our stack. It's not complete, of course. We use GCP, Google Cloud Platform, and we use Google Kubernetes engine, so it's much easier for us to manage our Kubernetes instance. And we have 2 clusters. These are pretty small clusters, but still there are 2 of these. We don't need development cluster because devs develop at their own machines. Okay, let's move to staging. At staging, you will see printables and eShop as examples of applications. And then there is running Prometheus and Loki. Loki is for logs, but let's talk about Prometheus. We use Thanos sidecars because at our production cluster there is running Thanos that can actually offload our metrics to object storage. That is called Google Bucket. And even in production cluster we have Prometheus with Thanos sidecar, but you can actually access Prometheus and production directly. We don't have ingress for Prometheus at stage because it doesn't make sense. We use that Thanos sidecar. Okay, this is how our alerting looks like, because I think alerting is pretty difficult to set up. And we use 2 approaches. Because we use 2 approaches in deployment, we use 2 approaches of alerting. Let's say we have Terraform, now OpenTofu, if you heard about that, and we use Argo CD with crossplane. You probably heard about that. You can actually use Terraform just for spin up of cluster. We use that for internal tools, and then we use Argo CD for our applications. So that's the reason why we use Prometheus Alert Manager for alerting about our cluster and tooling. And then we use Grafana alerting for alerting of applications. So our developers can easily ClickOps way create their own alerts, and they see everything they created. But actually, I am the one who creates these alerts, and just the developers can see how this works. We use our pipeline is that we use Slack, and then escalation is our on-call solution. Why did we choose Prometheus? Okay, because for us as DevOps department, it's open source. I'm not talking about WoW of our company because I'm in DevOps department. For our web applications, I'm not in development. And one of the reasons is open source. And it's part of CNCF. We are heavily CNCF based. We have most of our tools are from CNCF, so it's a logical choice of using of Prometheus. Next is widely used. If you have issue with Prometheus, probably someone already solved it. Then exporters for everything. There's a lot of exporters. We use them also. For example, Node exporter. Everyone should know that. PHP FPM exporter. Then even Minecraft or Counter-Strike exporter. If you want to, you can export every single metric you want to Prometheus and use it however you like. And it's very easy to implement your own exporter too, because we actually created body Prometheus exporter. I will talk later. But you can, let's say, have Python application, and you can create your own Prometheus exporter inside your application. And it just works. Pretty easy to config at first. It gets difficult later. But what about the printers? Yeah, I'm here about the printers, not only about our infrastructure. What if I told you that you can observe our printers with Prometheus? And here we go, body Prometheus exporter. This is actually body. This is Joseph's boss, Joseph dog. And our boards are called body, X body, XL body, body for Prusa many. But we don't expose metrics from the printers itself. So there is I needed to find another way. And it's kind of cheat way because Prusa boards expose Prusa API, Prusa API. And I use these endpoints that expose metrics about telemetry about how it's printing, status of job, printer version and such, and transpose them to Prometheus metrics. Of course, I use Prometheus as backend for metrics and Grafana dashboard for multiple printers. Right now, there is implementation for body-based boards. It's MK4, XL, MNA. And NC support is experimental because the exporter is in alpha. It worked before, it doesn't work right now. Sometimes it works on my machine. And let's go here. Yeah, this is our body boards. As I said, every single of them expose Prusa API. How to get data to Prometheus? You need something like Raspberry Pi. I used Raspberry Pi 4 and even 3, it's enough. If you are running Prometheus at this device, you will probably destroy the micro SD card that you use. So I chose Grafana Cloud. Let's ask, but why? Yeah, it's hardware. It doesn't need to be observable, right? Yes and no, because if you don't know it's something wrong, then you will be happier than if you know it's something wrong, right? I wanted to get data from printer to Prometheus or something like that. It doesn't need to be a Prometheus. And I want to create my own dashboards. Grafana is actually pretty great for this. Custom alerts. I can imagine that, let's say, on university, you are printing your own model on printer. Somebody came along, want to print their own, and said, scrap it, 60%, and it failed. Yes, of course, it failed. And in Grafana, you will see that print was already actually stopped, and it's not that it was it failed. And of course, the answer, but why, is why not. I wanted to prove it's possible. It was at first a proof of concept, and wanted to get better in Golang. and better understand Prometheus ecosystem. How does it work? Standard Prometheus exporter with standard libraries, nothing fancy, Golang 120, and it triggers Prusa endpoints. Every single scrape. That's kind of issue because if you think about it, every printer have 4 endpoints, and if you have 1 printer, and 4 endpoints is pretty great, nice. You have 10 printers, it's 40. You have 100 printers, it's 400, and so on, so on. You still need Raspberry Pi or something like that. Not necessarily Raspberry Pi. You can use x86 server if you want to. And you need to run Grafana Perses, as we heard today, or whatever. It's in Prometheus. You can visualize it anyhow you want. I have all over dashboards for Grafana right now, only. But what about more metrics? We actually not expose, but send our metrics. It's the official way in quotes in syslogs format with UDP to our internal server, like inside of our company, and you can actually send them to your syslog collector too. Or you can use InfluxDB by default. You can find source code in our body firmware repository. And that's why I created body observability collector. Body observability collector is in experimental stage early. Sometimes it works on my machine. And PromTail as a processor of logs, because I can regex every single metric I need. There is implemented only a few of these, and expose them as such metrics for Prometheus. As I said, more like proof of concept. It works. And I use also body Prometheus exporter as additional source of data, because there's some kind of some data in Prusa Link API, and then some data in syslog exporter. But what about that farm? Yeah, that's something that is, let's say, issue, and it's complicated. Right now, solution would be syslog UDP plus InfluxDB, at least 50 kilobytes per second per printer. It's much higher while printing, like 10 times more. And about 600 printers, 600 by 1500 kilobytes per second, that's a lot of traffic. It will easily destroy our network. And data needs to be parsed. They are not in standardized format, so we have actually right now script in Python, and that doesn't run pretty well. And now, status of our farm is we have a lot of MK3 printers. We have metrics from these printers actually, and it's terabytes of data, terabytes, because we are printing for a long, long time. And these are just data. We have no proper visualization. So as I always said, that if you have too much observability, it's almost useless as no observability. Because if you have data, but you cannot visualize them, it doesn't make sense to create, generate these data. Eventually, we will, of course, upgrade to MK4. And that gives us opportunity to do it differently. And of course, there are a few excels at farm, and these are same as MK4 as terms of endpoints. Future is the meme on the right. It's not true anymore because we actually released 5.0 firmware for Prusa Mini with input shaper. But who knows what is the future? Maybe OpenTelemetry. Actually, at DevOps, we already use OpenTelemetry, and I'm really too happy to hear that Prometheus support will hopefully support OpenTelemetry. Actually, I know it because there was a blog post. And we use Prometheus in backend, so it will be awesome. But why we use OpenTelemetry is because tracing. That's the main reason. It will be so soon a trademark. So hopefully some kind of solution will be done soon. or can it be my Prometheus exporter for body, or it will be in firmware? Who knows right now? Syslog is in firmware now. You can actually use it, start Docker Compose up in our repository, or you can use body observability collector. It's open source. You can contribute. I will be more than happy. And last but not least, body Prometheus exporter is in alpha stage right now, but it's available. You can use it. Probably I wouldn't change metrics, but still it's alpha stage. So it can work now, but not tomorrow. Okay, how does it look? This is one of the dashboards that I created. It's pretty harsh, rough on the edges, as always when you're creating dashboards the first time. It's a dashboard from February, March, maybe. I didn't updated it, and it looks like that. As you can see, there's a lot of information. There's target nozzle temperature, target bed temperature, everything you need to know while observing the printer. And of course, there's one issue with scraping these 4 endpoints, and if you're have your scraping interval like 10 seconds, then sometimes printer doesn't have enough processing power to answer. So you will have no data for that at that time. Or it can look like this. Let's say you have farm, you want to have a lot of printers, and you want to visualize every single one of them. What is the printing, if it's in failed state or something like that, and what types of printers you have. See, there's one MK4, 2 minis, and one MK3. And of course, INSEE have much more metrics because it runs Prusa link at Linux, and there's much more information that you can actually ingest. I will show you a demo, hopefully. Here? No? Okay, this is running at Grafana code. Unfortunately, I forgot to start printing on the printer. But never mind, you will see how it looks if it's not printing. And by default, the app exporter is multi-target. I have more than one printer, so I wanted multi-target exporter. Here you see information about the printer, and if you go here, then you will target temperature, success, and version of Prusa link. That's different for Prusa menu, of course. There is now it's the same version, but before it wasn't. Number of files, what you are printing, Z8 in time, a lot of good stuff. Actually, there are even syslog, but unfortunately there are no data. But you can see there is information about 5 volt voltage, 24, and current, the adjustment. While it's not needed, of course, because it's an extruder, but you can actually adjust at MK4 or XL. And there are nozzle current, nozzle voltage, a lot of interesting things you can use and experiment with. And this is the overview. As I show you, there was multiple printers. Right now there is one, and there's no mini. But I don't know why there is no mini. It should be there should be something. There should be just MK4. Okay, and of course there's a live demo at the Grafana booth. You can watch how it works. It's in alpha stage, but so I needed to start go run dot and started Prometheus exporter outside of Docker Compose up because it didn't work. Something with network, and thank you. That's it. Thank you for your everything and time for questions.
Thank you so much. Do we have questions? Okay, Kemal, do you see? Yeah.
Thanks for the talk. So printing is sometimes a black box. Once I was printing something 5 times, worked flawlessly. Next day I printed the same thing and it failed 10 times in a row. Can I use any of this to detect print failures or a reason about why something fails?
Well, of course you can, but it depends, as always. You can set, for example, alert that you have 68% of print done, but print speed is 0, for example, then you know if it failed, and you can, for example, there could be issue with heater, and you can see that, for example, peak of temperature at nozzle, for example.
Okay, thanks.
Please, if you have a question, raise your hand so we can already come to you just in case.
I'm curious about how do you scale up when you add more printers? I mean, you have a Raspberry Pi there. Okay, it's not really Prometheus related question, but still, I'm curious how you scale up. For example, do you have some kind of distribution which automatically, when it's deployed, when it's installed in the SD card, it connects to the rest of the network? How this is done?
That's the issue that we are occurring because we don't. Well, right in the company is used that syslog solution of metrics, and there was we were able to run only one instance of that Python regexec script. So it was usable for like 30 printers, and you need to run another instance and send data to another distance. And you need to configure printer to send them. There was I know that Internet IT made some kind of load balancing, but that's not something I know, honestly. And of course, in our Kubernetes cluster, there is handled scaling automatically. And if I can answer to that, Golang exporter, that it was in alpha stage, so I don't need to answer this question yet about scaling.
Any other questions? I guess then that's it. Go and check out the live demo at the Grafana booth. Very cool stuff. Here's your speaker gift. Thank you again so much. And one small note for the speakers who already have gotten their speaker gift, please open it and check that there's actually a Prometheus mug in the box, because we had some wrong mugs shipped to us. So please make sure it's the correct one. All right, we'll be back in just a bit. Yeah. You need water? All right. I think I'm going to do some talking, and then we'll start right on time. Okay, so this is the last full-length talk before the lightning talks, which are happening in half an hour. I think we have roughly 10 talks lined up for the lightning talks. I'm going to check again. For tomorrow, there's still plenty of space. Definitely make sure to write your ideas down tomorrow morning at the registration booth or throughout the day, obviously. Yeah, I'm super excited to have Bartek and Arthur on stage. Also, hi to Arthur's mom to Brazil.
Hello.
She's watching. And yeah, I'm really looking forward to your talk. I don't know what to say. Take it away.
Thank you, Matthias. Oh my God. All right. Hello, everyone. I hope everybody is still energized. Oh, thank you. Energized after a very long day of conference. Our talk will be about a limitation in Prometheus, actually. It's a precision issue, but I don't want to spoil the talk too much. I also wanted to say that this is really an honor to be here. I've been following PromCon for years, and this is the first time that I'm actually here, so thanks for having me. I am very nervous, as you might see, but that's why I'm actually talking a lot at the beginning, just to talk it off.
Are you less nervous now?
Not really.
We tried.
Yeah, but let's start with a short introduction.
Cool. Hello, my name is Bartek Płotka. I work at Google. I specifically work on Google Managed Prometheus in Google Cloud. I also wrote a book called Efficient Go. I'm active in the CNCF. I maintain Prometheus. I co-founded Thanos. And also, I started recently a podcast called Optimize All the Things. It's about optimizations to your life, infrastructure, work, everything. Yeah.
It's a little bit hard to compete against that. Oh, nice, somebody got it. Yeah, I'm just Arthur. Seriously, I'm a DevOps engineer at Curologics. I'm recently become a maintainer of Prometheus Operator. I used to be an SRE at Gitpod, and back in 2020, I was a mentee for KubeVirt. And right now, I'm a mentee for Prometheus under the Google Summer of Code program. And actually, what we are going to talk about is what we've been doing in this mentorship.
Amazing. I wanted to make a joke that I didn't get the Barpy joke as you, but you get it, so good job. Nevertheless, we are here today, and we're super excited to be on PromCon, our favorite conference, to discuss quite old counter limitation. And no, it's not about ability to decrease counter values. That's not limitation. That's a feature. But yeah, let me start with some short, quick refresher about counters. Hopefully you know that, but it's probably the first thing that somebody learns when they came into Prometheus, how counters works. But essentially, counter type in Prometheus represents a cumulative count of something, for example, arrow count, right? As we can see on the graph, for example, yeah, you can see the row counter value here, which represents a total number of errors that occurred on some server. The counter values should be always monotonically increasing. That's very important. Thanks of that property, whenever it decreases, we are sure that the counter was reset. For example, when the application restarts. However, the main value of the counter is not from its absolute values, right? Prometheus users actually rarely checks absolute values. What's really important is most likely the relative value of the counter, thanks to functions like rate, irate, or increase. For example, on the right, we can see a error rate over 1 minute that gives us a per second error increases. What's additionally nice about the rate functions is that they adjust for resets, so you don't need to worry about those things. And all of those properties, together with those rate functions, give us a really nice resilience for our production monitoring, right? This is one of the main reasons why Prometheus can be so cheap and reliable compared to maybe some other pure push-based solutions. Prometheus can miss some scrapes, sure. In many cases, it can still calculate a quite accurate representation of rate for our alerting and debugging needs, right? So that's why this quote from Brian Brazel, which was like 2017, is still very relevant. But the key aspect in that statement is a little bit cryptic, this average word, right? For some time, there appeared an opportunity to bring this average to the higher number and to have counters a little bit more accurate. But first, let's learn about this problem from the little story.
So once upon a time, there was a rabbit and a turtle. And yes, this is a true story, believe us. The rabbit and the turtle were training for this legendary race. It's so legendary that there's actually history books about this tale nowadays. So actually, Bartek and I were very lucky. We were actually there. We saw everything. We were actually consultants to their coach.
Yeah, very lucrative job. I can recommend.
Yeah, their coach, the coach was training both of them. So he wanted to make sure that the turtle and the rabbit would run 30 meters every single day. He even set up alerts just to make sure that they were training. How the experiment works is, oh sorry, I forgot a very important thing. The coach was using Prometheus, of course.
Of course. Right.
He was using Prometheus to monitor the training. The Prometheus was scraping the app that was exposing data about the race every 10 seconds. And Prometheus would only be able to see the data if the animal crossed the start line. If the animal didn't cross, then Prometheus has no idea that the animal even exists. So yeah, both of them went to the racetrack. Camera person, I'm going to make you work. So both of them went to the racetrack, and we all know the turtle is a very hardworking animal, and immediately started his training. Bartek, do the thing.
Ready, set, go.
Yeah, the turtle was not very fast. So the rabbit saw the thing, how the turtle was super slow, and just thought, what a clown. I'm just going to take a nap, and I'll start when I feel like it. So the rabbit, and meanwhile, Prometheus made the first scrape. Turtle was already 10 meters away. So the turtle crossed the start line. Prometheus knows the turtle exists. The rabbit was competitive even in his sleep, and after only 10 seconds, it already has woken up, saw the turtle in the 20 meters mark. Prometheus scraped. But the rabbit, notice how the rabbit is not on the start line yet, so Prometheus has no idea that the rabbit even exists. But yeah, when the rabbit saw the turtle in the 20 meters mark, he immediately started to swing. And the third measurement, Prometheus scraped, and both the turtle and the rabbit were in the 30 meters mark, finish line. Okay, sorry, I'm breathing hard now. So Bartek and I were there, as we mentioned, and we saw everything. But all that the coach had was what he could query from Prometheus. So the code showed us his Prometheus instance, and the data looked super weird. Like, the turtle starts 10 meters, okay, it's kind of acceptable, but the rabbit started at the 30 meters mark. Like, how could he finish the race, the training, if he's already at the 30 meters mark? The rate function, like if we're rating over the travel distance, what we are showing is actually the speed. And how could he finish this training if the speed is 0? It doesn't make any sense. So, as we mentioned, the coach had alerts to catch lazy students, and every single day he would get alerted about the rabbit who finished his training with speed equals to 0.
Yeah, we want to help the rabbit, of course, right? To show that they actually made the training. So the issue that Arthur explained is not that rare, right? It is a kind of very common thing, and the common kind of pattern information that would be useful in those cases is if the counter that we see, the counter value, the first sample that we see and Prometheus scraped, is it a new created counter that just was created, or it is an old counter that we just didn't see what happened before, so we cannot assume anything. And you can see that in this example. So for example, here we see the number of counts again, but with some gaps. Like in a real production system, we might have some gaps, right? And gaps may be because the service discovery were misconfigured, or some hiccup, or just delay, or network blip, or Prometheus just restarting because you are upgrading a version. Unfortunately, this is where we seem to be, like failing this average, well, below average correctness of Prometheus from the Brian quote, because Prometheus cannot really tell much from this situation. For example, first few samples, we cannot tell really if this 200 value is for a new counter, so just recently increased, like literally before, or it is an old metric and this increase happened like 2 days ago. What's even worse, in a second batch of samples, Prometheus can tell if there was a metric reset between those two streams. And if there was a reset, then we should kind of accumulate we should represent a large increase. Maybe there was no reset, which would be only increase of 10. So that's really important, right? In other words, we cannot tell if this situation represents, this situation, or this, or any other kind of unlimited options that might have happened. And the result is kind of like tragic because we don't really have, we would not alert on maybe important information about, high error rate because Prometheus stays on the safe side and essentially decides that the rate is 0. So this is really important. And there are 2 known mitigations. You might know some of them. So let's go through that. First of all is the PromQL magic. Can you raise your hand if you understand quickly what's happening here? Go, 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 go. 2 more seconds. Whoa, yeah, 2 people, 3 people, nice. So this is actually kind of like relatively straightforward. Essentially what it kind of tries to do is like you have a rate, you kind of care about your rate, but then you kind of check the edge cases using aptness metric. Hey, what was happening with my scrape situation just before, like 1 minute before? So you could assume some kind of existence of this counter being there or not. So, but it's very complex, prone to errors, very hard to read. So what we rather recommend usually is to initialize your counters. You probably heard about that. I think we were talking with Kemal about this like, I don't know, 5 years ago. But generally, how you do that, for example, in Golang, you just initialize your dynamic labels with known values. So for example, for HTTP requests, we know that most likely we'll have some successes and some not found errors. So we can populate those and put 0. So we'll be exposing a new metric with those with the 0 value for 200 and 414. But it's not applicable to try to predict all the labels or even pre-populate all the status codes you would have, because that would be hundreds of or thousands new metrics that you might never use. So it's just a waste. And also, sometimes you cannot predict the values, right? So, so this solution is not very reliable. Fortunately, the created timestamp kind of idea existed for a long time. but it got more popular nowadays with in the CNCF observability. First time I personally saw this solution, this kind of like improvement, is when I joined Google this year. And because such technique, such kind of thing is required when you ingest the data into our monitoring system called Monarch, right, at Google. Because kind of Monarch really cared about accuracy of those counters, so they build that in and actually require on every ingestion. So created timestamp, semantics, is essentially a piece of created timestamp is essentially a piece of metadata that you associate with samples, with few samples, and it tells you for sure that the counter started, the counter value 0 or reset was exactly at this precise moment. Essentially, in this case, visible on the screen, is super important information, right? Because the absolute count, if we just try to adjust for the reset for those samples would be 15 in Prometheus, right? But the truth is, thanks to created timestamp, we see that actually we missed some scrape, and between 10 and 15 there was a reset. So the actual absolute kind of count value would be 25, and that's kind of very, very important.
Okay, so in the Prometheus ecosystem, at least, the first appearance was made by OpenMetrics. OpenMetrics says that every counter, summary, and histogram should optionally add a timestamp that represents when the counter, summary, or histogram is first initialized. It is mentioned in their specification that the intention is to help ingester to discern between new metrics and long-running metrics that Prometheus just happens to see for the first time. A few years later, OpenTelemetry also came up with the same idea. It just changed the name slightly to StarTime Unix Nano. So we all know the semantics now. So what can we do to get created timestamps into Prometheus? The first step is instrumentation. Let's talk how can Prometheus scrape created timestamps from an instrumented app. Candidate is OpenMetrics text. Prometheus already accepts OpenMetrics text, and OpenMetrics text also has created timestamp. So why not? So the problem is that it's a little bit complicated to accept OpenMetrics in Prometheus. The way Prometheus interprets the text is, as you can see, this is kind of two series. One for full total. Yes, one for full total, and a second metric for full created. There's also the problem that there's nothing stopping a user to create a gauge called full created as well. So the name of the created timestamp of the counter clashes with the name of the gauge. We could improve Prometheus to somehow parse that, and like we need to maintain a complex code to make the created timestamp as a self-contained thing. So if you're just ingesting as metrics, an instrumented app that has mostly counters would potentially double the amount of resources that Prometheus needs to have just to ingest the created timestamps. And finally, other protocols do not treat created timestamps as a other time series. It is a self-contained thing. So instead, we decided to use the recently resurrected Prometheus protobuf, mostly because Prometheus protobuf already supports native histograms. Thank you, Bjorn. So as we can see, and on the left is OpenMetrics protobuf. OpenMetrics protobuf already has created timestamps, and in the right is OpenMetrics protobuf, and the left is Prometheus protobuf. We are doing the same thing. We are basically just adding optional created timestamp to counters, summaries, and histograms. And during the design process, we came up with two ideas for the storage implementation. We already implemented one. And this strategy is what we call zero injection. If the created timestamp of the time series being exposed is higher than the timestamp, sorry, English is a little bit hard. it's a little bit, it's higher than the timestamp of the previously ingested sample. Instead of ingesting only one sample, we ingest 2. It's a little bit hard to see, but this one and that one are green. The green ones is what is injected 0. The timestamp of the sample is equal to the created timestamp that is exposed by the app. And after we inject the 0 sample, we ingest the usual time series exposed by the app. And it has advantages. This is a fairly simple implementation. We don't need to change a single line of code in the rate function, and we already see amazing results. But also comes with a few downsides. We cannot ingest created timestamps out of the head hinge. So we are a little bit limited about how old the application can be, so we can inject the 0 sample. We already have a few ideas to improve that, but they are not implemented yet. Okay, so let's go back to the training. We kindly asked the coach to upgrade the Prometheus to the version that we implemented. And in the left, we see the new results. Like the new results, we can see that both the turtle and the rabbit starts at 0 and not in 10 and 30 like before. We also see the differences on the rate without changing a single line of code. The rabbit is not teleporting to the finish line. It's just super quick, and Prometheus could not see that.
Yeah, but thanks of the...
Oh, sorry.
It's fine, should be fine now. Yeah, but thanks of the created timestamp, we can kind of know much better what was happening, right? And this is the same kind of for our error counts. As you remember, now exactly just the same situation, if we just apply created timestamp, it would look like this. So not only rate just works, it's also visualization is much more understandable, right? Just you need to be careful because perhaps if we accept this change, you might have some zeros, some samples that are not scraped samples, they are created timestamp samples. So you have to be a little bit, just be aware of this. But generally, it should help, that implementation should help enormously. Because, again, with this more, more information in our error count, we can kind of finally see the increases, and they were kind of quite large, so we would miss an, error spike. Okay, to sum up, how you can use it. So generally, it's in progress. I mean, the code is there, it's being tested, but we have to accept it. We have to merge it. We'll be talking about that on Saturday, the summit as well. But essentially what will happen is that you can upgrade, if you use Golang, you can just upgrade client Golang, and thanks to Arthur release yesterday, you can just upgrade it, and it will have created timestamp kind of emitted from your instrumentation. Then it's just as easy as once we merge, upgrade Prometheus, and there is a new configuration change, most likely, for scrape config, for scrape job config, where you can choose what protocol you would use to scrape. And this is where we would probably go for Prometheus protobuf exposition format as a recommended kind of first choice. And you will be able to configure that. Maybe we can change that, as a default option in 3.0. I don't know. Let's see. But this is something you have to be careful. Now, there is call for action as well. We would love other instrumentation libraries to also emit created timestamp, maybe use Prometheus exposition format. And also, we want contributors to kind of like get other protocols to be useful with created timestamp. And that's totally possible, just amount of work to be added. So even OpenMetric Proto and OpenMetric Text can be kind of like supported, like Prometheus can be able to kind of parse the created timestamp from them properly. And before we finish, a few words about open source mentorship, right? I can tell you from my perspective, like mentoring is amazing. We should do it much more often, and especially in the CNCF, there are lots of opportunities because CNCF participates in Google Summer of Code or Linux Foundation, and it's for everyone. So, Arthur, was it useful for you?
Yeah, of course. As a wise man once said, you are an average of the people you are surrounded with. Naruto Uzumaki. Oh, sorry, I'm spoiling things. So yeah, of course. 3 years ago, like just some context, 3 years ago, I didn't even know Go syntax. Like, I was a complete beginner. And now, 3 years later, I'm a Prometheus operator maintainer. I was client Golang maintainer for 1 day, but just details. Yeah, it's very clear to me that I've improved a lot with hard skills, soft skills. So I want to thank everybody in the community who spent time to help me. It's really, really important.
Yes, so hopefully we kind of, I don't know, you can jump in as well. So the point is, you were a massive help to us, Artur, as well. So it's kind of like both beneficial to both mentee and mentors. We get to finish features, we get to empower new people in open source and really in programming as well, and potentially have new maintainers, right? And if you are interested to be mentored or mentor others, like you can go to this website, you can ask us, we can guide you. But my point is, like, we can make mentorship real. So even if you are just contributor to Prometheus, not maintainer, you can mentor others with the Prometheus, for example, team member. And you can if there is a feature that will be accepted, we can work together and mentor together, right? For example, I co-mentored with 2 other people from Google, and outside kind of a contributor to Prometheus.
They're not maintainers. Right?
Yeah, and they are not maintainers, and they were totally helpful. So you can help as well. Please help us mentor new people in the community and make things empower new people in this space. So that's it from us. You can reach out on those Twitter handles or X handles. We want to thank you to our commentors, Max and Daniel from my Google team, who helped mentor Artur. And thanks to those companies, Google, Corologics, CNCF, so we can mentor in the open. Thank you.
Thank you.
Thank you so much. Do people have questions? You should know the drill by now.
Understandable topic, I guess.
Oh, all the way up, come on.
Oh no, it's just dark there, yeah.
There's your workout.
Hi, thank you for the talk. So do I understand this correctly that the fix you mentioned is merged in Prometheus now, but not released in a version yet?
No. We have a working implementation.
In the pull request.
In the pull request, tests are still not there, but will be. Once we get merged, then yeah. But it's not merged.
Okay, thank you.
Hi. Have you done any benchmarks to see whether the response size is going to increase drastically when we add this additional created timestamp to each time series, or each sample, basically? That's
response size of what?
Of basically the client exporting metrics. So the protobuf size, essentially.
Benchmark on the client side. I don't think I've done anything.
No, but it's another field in protobuf, so it should be fine. And also, like, every other protocol do that, so it's also like they kind of accepted this penalty. But yeah, you're right. We will do benchmarks to kind of show the difference, but it should be like negligible.
Yeah,
it's only one integer, really.
While people are thinking if they want to ask a question,
just one more, maybe last one. Yeah.
We are going to prepare for lightning talks. So Augustine and Raphael can already come down, and maybe Hayu Son and Daniel can also start showing up.
Yeah, thank you. I'm not sure if I understand it correctly, but will this force a change into the TSDB format, and will other tools like, for example, Thanos Sidecar can be able to use this?
Yeah, no. Like, since we are appending a sample to the TSDB, there's no changes to the TSDB. It just works.
That's the beauty of this solution, yeah?
Yeah, perfect.
Okay, thank you, everyone.
Thank you. I just forgot the microphone. That happens. I was so obsessed with the lightning talk. So this is going to be a slightly more chaotic, but also a super fun part of PromCon now. We'll start with Augustine. You need my MacBook, so let me get that. Can you hold this? Okay. I guess we can just get started. We might as well just leave early to our social event. Okay, so first, yeah, Augustine, Raphael, you're next. And you have 5 minutes. You'll see the counter here, and I'll start annoying you if you take longer. So here's the microphone, and I'll hand the handheld over to the next speaker afterwards.
Okay. Thank you. Hello again. I'm still Augustin. I'm still working in Amadeus, and I'm still a Prometheus team member. Today, well, I will talk about Alert Manager UI today. Also, especially because I want to announce you, we are going to restart from scratch the Alert Manager UI, and this is why. It's coming from a simple constat, a simple situation that Alert Manager is made with ELM. I have no idea if some of you know this language. I don't personally. And I spent a lot of time to learn React, and when I saw that Alert Manager was built with ELM, I was like, okay, so I know I have to learn another language to build UI. It started to be a lot of things in Prometheus ecosystem, so maybe we can change something here. And after a lot of talk with Prometheus team member, we reached the consensus that yes, we are going to change that, and we are going to restart the Alert Manager UI using React. And the next question will be which library we want to use. You have to know that Prometheus, PromLens, Thanos, and also Alert Manager is built with Bootstrap. But if we are going to restart from scratch the UI, why not to explore other UI libraries such as Material UI, Semantic UI, or Mountain? That's still an open question, if you are wondering. I personally like Material UI, but it's just a matter of opinion here. There is nothing really hard. And since we want to try something different, why not taking some inspiration from the Karma? Maybe you have heard about this project, and I think the main maintainer is in the room. Thank you for doing that. I kind of like it. It's maybe there is maybe too much things for the Alert Manager UI itself, but we can take a lot of inspiration and can inspire to see something, to try something different. It's already started. We merged the pull request that initiates the React application 1 month ago, at the end of August. So now it's ready to receive open contribution if you want. And please, if you want to help, you are more than welcome. And yeah, it's open contribution. Thank you very much.
Well, thank you. Awesome. You have your own notebook? Yeah. So. Is it okay if we just unplug them, or do? Okay. Don't look. I need to you plugged in. Okay. It's coming up now. Yeah.
Maybe I should use
Sorry? No, you're good. It's here. If it shows up here, then we'll turn it on once it's ready and you're ready. So, yeah. Okay, perfect. Thank you. All right, here's the mic. Thanks.
Hello, my name is Raphael. I'm working at Crideo as a site reliability engineer in the team in charge of the observability, hopefully. And I'm going to talk about how to implement integrals with PromQL and Grafana. So as a short intro, let's look at what an integral is. So it's the sign area under a curve. It's also its continuous sum. It's often seen as the reverse derivation operation. So now in Prometheus, we deal with time series data, so it's sparse, it's not continuous. So we'll need to approximate it using Riemann sums, which are dividing the curve into rectangles. Now, what would we need an integral? So it's kind of the opposite of what we talk about today. So you might have a metric that is a rate of something, and then you want to go back into its counter form, so its cumulative form, over a period of time and starting from 0. We also have some other systems, such as Graphite, StatsD, that expose such a metric, and you might send them directly to Prometheus. So in our case, we had a Graphite metric that was representing the money gained over a minute, and we wanted to have the evolution over time, so over a few months, and see whenever it was reaching certain levels. So to do that, we'll use a pretend metric, so this delta metric. We know that its counter form should be monotonic and only going up, and we'll try to build its integral over the last hour. So the sum over time seems to be a pretty good candidate, but when we apply it, it's not really what we expected. In this case, it's going down, it's not monotonic, so that's not exactly it. So what we need to do is, in the subquery, filter the points that are only within our 1 hour time window that we selected. So we know of the time function in PromQL that returns the time on which the query would have been executed, and we can compare that to our initial timestamp. So timestamp now minus 1 hour. This seems to work, so we have a good candidate, and if we apply back the sum over time, we have some counter-like metric, and it's the integral. Now the next step is to make this query reusable, because on this we have the initial timestamp and the range set manually. Now enters Grafana. So Grafana provides some global variables where you can use in queries. So we'll use the range variable to fit automatically the integral in the selected range, and we'll use the from variable in seconds to match the time function. So now we have a query that we can reuse in dashboards that will fit automatically to the time window that we want. One last thing is sometimes those queries are actually quite expensive, especially if you have a lot of metrics and you select, for instance, years. So something you can do is use bigger steps. So instead of having a step of 1 minute, you can use 10 minutes, 1 hour, or whatnot. The only thing is you need to multiply the results accordingly. So an hour will multiply by 60 compared to the 1 minute. Just note also that the bigger the steps, the less precise you are. Anyway, thank you. I hope this will be useful to some of you.
Super nice. I learned something. I mean, wasn't the first time that I learned something today, just to make sure, right? But it was a great talk, that's what I'm saying. Yeah. Okay, if it shows here, we're good. Something is happening. Yes. Are you drawing or something? Okay. Okay. Perfect.
Hello, everyone. My name is Howie from the Red Hat OpenShift monitoring team,
And today I will present 3 ways to ingest the OpenTelemetry metrics into the Prometheus. So the first, we can use the remote write and with the OpenTelemetry collector, or we can send the metrics directly into the OTLP native endpoint of Prometheus. And also we can script the metric endpoint on the OpenTelemetry collector. So so when we use the remote write, we need to set up an OpenTelemetry collector to receive the OTLP metrics from the application and translate them into remote write format and send to Prometheus. And by using this method, we can take advantage of its best compatibility and efficiency, because the remote write is the native protocol for Prometheus to receive remote metrics. And also, it's a very popular protocol, and we can leverage the existing operational knowledge on these kind of protocols. And also, it provides some resistance to small disruptions thanks to the write-ahead log. And there's something to consider is that sometimes it can be complex to configure and maintain this setup. And the remote write requires a fine-tuning to guarantee its best performance. And also, since it's a push mechanism, we can overload the Prometheus if we are not careful. And the second is we can directly use the OpenTelemetry endpoint on the Prometheus. We can either send the metrics directly into Prometheus or use an OpenTelemetry collector as an intermediate. And the second can resolve the problems if we have too many endpoints and we hit the limitation of connections. We can also do some transformation in the collector. And the advantages can be we do not need to translate between remote write format and OpenTelemetry format. It can save some resource. And also, it can save time for the application developers, because they do not need to set up additional components. They can transfer the metrics directly into the Prometheus. But we need to pay attention that the OTLP endpoint is kind of new in Prometheus, so that there can be a potential impact on the performance and reliability. And also, we should pay attention that the labels can they can change between the 2 formats, and it can be different from what they translate in the remote write method. And the third is that we set up OpenTelemetry collector in between the application and the Prometheus, and the Prometheus will just scrape the metric endpoint on the OpenTelemetry collector. And for this method, it's a pull mechanism, so we can totally avoid the congestion on the Prometheus side. And we can integrate rather easily with the existing Prometheus-based monitoring system, and it provides the best reliability. And there is something we should pay attention is that we should wisely set the scrape interval to avoid losing the precision. Also, since it has a collector in between, it can add some complications into the operation. Let's see the performance difference between the remote write and the OTLP endpoint in Prometheus. And the orange line is the OpenTelemetry endpoint, and the blue line is the remote write. You can see that from when the traffic goes higher, the difference is becoming more obvious. When the traffic is reached like 10,000 items per second, there can be a 30% difference in the CPU use. The OpenTelemetry endpoint just use more CPU than the remote write. And in terms of memory, it is just proportional to the items we start. It is not much big difference between these 2 protocols. And just thank you for your attention. It's the end for the presentation, and you can get the slide on this QR code.
Hi, my name is Daniel Moore. I'm an engineering manager at Red Hat, work with the OpenShift monitoring teams, and I want to show you a small side project I did today. So one part of my job as an engineering manager is to also try to understand industry trends and how they might influence what we should build. And yeah, in OpenShift monitoring, we're quite heavily relying on the Prometheus ecosystem so far, but there's a new kit on the block, as you know, which is called OpenTelemetry, and we're actually already shipping an OpenTelemetry collector with our OpenShift distributed tracing product, but it looks like that it also becomes more relevant for monitoring recently, so I try to understand that a bit better. And I picked a use case, a limited use case for that, which is a very important use case for Red Hat. It's resource-constrained environments, so edge use cases. This is very important for OpenShift and for RHEL, especially in telco industry, automotive industry, and other industries. So what's common in these edge use cases is that you're usually using a pure scrape and forward approach. So you're not storing metrics locally and also not querying them locally. You have restricted resources. You also sometimes don't really have an inbound network connection. You have to kind of push the metrics outside of the cluster. So this is how the architecture usually looks like. So there's a monitoring component running on the device or on the cluster, which scrapes the workloads and directly forwards it out to a remote storage where then the alerting and querying happens. So what I did was I created a few configurations based on Docker Compose. Avalanche is producing metrics. I use Prometheus as the remote storage, and I try to set up and measure 3 configurations here. One, Prometheus agent with remote write, OTL collector with OTLP, and OTL collector with remote write. This is the link to the project. You can scan the QR code if you want to look at it right now. And then I'm measuring that, so I run a CAdvisor container besides that, and the Prometheus, where the metrics end up, finally also scrapes this CAdvisor. This is where the data comes from. So let's look quickly at a few results. I don't really want to interpret them a lot because I'm really not the expert in the technicalities behind that. And also, I didn't do any fine-tuning of either remote write or OTLP. If you need to tell me whether these results would look differently if I did some fine-tuning. I would really be happy to learn about that, so please reach out if you know better. So you just see that Prometheus agent with remote write seems to win in the CPU case. I have 3 metrics granularities here. It's 1K active series, 50K active series, and 200K active series. Let's look at memory. There we see that OTLP performs quite well compared to remote write. But the remote write implementation of the OTL collector seems to be also quite heavy. So net receive is also quite similar, so they all look quite the same. Prometheus agent with remote write seems to win everywhere, except the net transmit is also what we heard in the morning, that the OTLP implementation is a lot less heavy on the network. So their remote write has some drawbacks. That's it. Thank you. You can find me on GitHub, Twitter, LinkedIn.
Here's your swag. Do you want swag? Sorry. you can just watch it there as well. Yeah, you need to move it down, and then the clock is always in. Yeah. Okay, perfect. There you go. You don't need to.
Okay. Hello, everyone. My name is Daniel Mellado. I'm also a team member from the OpenShift monitoring team. Basically, most of my background comes not from monitoring, but for SDN. And I thought a little bit about, okay, what can I do to basically get both of us together? So as I assume most everybody knows what a CNI plugin is, but I'll just want to do a quick recap. In case you don't know, a CNI plugin, which stands for Container Network Interface, is basically the plugin that you are using whenever you run a pod and network magic happens. This was originally not even meant to be used by Kubernetes at all. That's why we don't have any kind of daemon or whatever. And also, some of you may be wondering why we are using JSON instead of YAML. That's basically why. The good thing is that you can use it with no Kubernetes harmed. You could use Podman. Well, they are somehow migrating to Netadar, but that's another topic. You could use Docker. If you are just running Docker, they're using a lot of CNI plugins. And besides, okay, let's now talk a little bit about the Kubernetes use case. So CNI is basically a set of plugins maintained by the community. It's also some kind of libraries that you can use to create your own CNI plugins. And it's also a binary, which of course is written in Go. But okay, you can also do things with no Go harmed. I've been done CNI plugins with Python and even Bash. Okay, they were crappy, but they worked. So you can just somehow try to go with this. And in the end, this is just a binary, which is executed by the kubelet or CRI-O, depending on your schedule. Let's go super quick here. Basically, whenever you got a CNI plugin, you got a set of envvars, which you are basically exposing them to your things, and standard in. You got the CNI version, which is the only mandatory field, and also the type. Okay, let's go all together. It works. Let's say you run a pod, and something, okay, it doesn't fail. You exit code 0, it works, then you got the network here. There's basically like 4 different CNI commands in the specification. Just add, okay, I just got a new pod. Okay, give me port. Del, you want to remove a port, and then second version. Those two are, well, not really mandatory because they are not always used. We are migrating basically to CNI 2.0, which would have a lot of more things. If you want to hook me up later on, I can speak about multus and multi-networking and so forth, but for now, this is enough. I also want to speak quickly about CNI chains. Okay, we got CNI, which is a plugin. We got a plugin we call add. But what's the plugin here? So you can either get this JSON here, which would just call your plugin, but you can also have CNI plugin chains. CNI plugin chains means that you can just put several chains, several plugins in chain, in serial mode, and you can have, I don't know, PTP, bridge, whatever. So why not let's try to leverage this a little bit here and use this for something that would be interesting of metric and so forth. Because you can say, okay, you got the node exporter, but the node exporter would only have, you wouldn't get any super low-level detail over here with the node exporter. You may know a little bit about, what you are using in your node, and you're, I don't know, maybe, okay, let's give it a vote. You got observability operator, you got something that you want to use, and you also got network observability. Okay, fair enough, but you wouldn't ever get to that level. And in fact, if you don't have Kubernetes, how do you deal with that? So I know everybody knows about that in this room, but I just wanted to give a highlight about the data I had. I'm putting up a repo for that, so if you want to contribute, feel free to hook me up and we can have a chat later. But the main idea is to have a custom collector that would just go and react on the CNI custom commands, and then we would have just one of those chains and recapping. This is not a full plugin, because when you have several plugins chains come together, you are basically hooking up the output from one single plugin chain to a new one, and so on and so on. So you can have whatever the amount you want to use. I'm not going to be speaking about multi-networking, but anyway. But this is the main idea. Then you have an exporter, let's call it CNI exporter, and you would be good to go. Okay, I've been being super fast, but feel free to hook me up for a beer. Speaking about that, contributors welcome. Thank you all.
We are flying through all of this. No one takes longer. Everybody wants to go to the social event. I see a plot. You ready? Yeah, seems ready. All right, then have fun.
Cool, thank you, Matthias. Hi, I'm Brendan O'Handley, a software engineer at Grafana, and I work on a squad that works with data sources. So this includes query builders, also includes the Prometheus data source in Grafana. And so I'll be talking about using LLMs to teach about PromQL. And this project was a collaboration between our machine learning squad and the metric squad, and product and design. And so we all put our heads together to figure out how we could help users learn about PromQL. So I'll start talking about our user problems. I'll show a quick demo. I'll talk about the tech and then the next steps as we're still developing this. So the user problem is people who are onboarding to Prometheus will look up queries. They will research things. They will Google, and sometimes they get stuck. There is a steep learning curve often, and as a result, this can become an issue for some organizations. And so we proposed to include an AI-powered query assistant within the Prometheus data source plugin query builder here. And so we could see a drawer along the side, and this query advisor will help Prometheus users with a query recommender, a query generator, and a query explainer. And so let's see. Yeah, no volume, but I can talk through this. So we're selecting a metric here on HTTP request durations. We are opening the drawer, and we are indicating that we have a prompt. We have a question. We know what we want to query, and so we ask the AI, how many requests returned errors? And we can submit this, and we have a query generated for us. We can also click the explainer, and we get the query explained. So we can continue to ask questions. We can refine the prompt, or we could just have queries suggested, historical queries based on the plugin data source. And we can have all of these explained. We can continue to interact with the AI helper. We continue to ask questions, and we can use any of these queries in the query builder here. So, some of the tech that we're using. So we have the query recommender, which recommends queries based off of historical uses in Grafana. So that's the top 5 queries based on the metric selected. We have the query generator based on a user prompt. This uses LLMs and PromQL data to generate an accurate and a valid query. And then we have the query explainer, which uses the metric and labels and metadata to explain the query in plain English. So we have LLMs, we have vector DBs and embeddings, and we have simple search techniques helping out in this. Some of the things that we learned was that while we use ChatGPT, it has a vague grasp of PromQL. We definitely want to avoid hallucinations in suggesting queries to users. So lots of warning, lots of testings. It's slow to respond with more complex tasks. So depending on the prompt, this can take a longer time, such as the latency of LLMs can be quite slow, and the LLM requires natural language. So these are a few things we learned, and our team is still continuing to develop this. We are integrating it with the Prometheus plugin. That also looks like we're using these services in a machine learning LLM plugin itself. So this is helping us complete our backend services. We're also iterating on the design and continuing to test our output. And you can help us test. My coworker Catherine Gui and I are here at the Grafana booth if you want to join us and play around with it. We have an instance set up with it. So, thank you. That's it.
Thank you. The mic is always on. So, did you encounter any hallucinations while you were developing that are rather interesting to share?
No hallucinations, but we did have a lot of our engineers enter in goofy prompts to see what the weirdest responses they could get. But we do have some code defense where if it's nonsense that's entered, we say we can't generate a query based on that.
Okay. Yeah? Okay, cool. Yeah, I was expecting something goofy, for sure. Yeah.
Okay, perfect. I hope this is not going to be disappointed. I don't have to show a tool here, so it's slightly a different topic. It's about a blaming culture is not your fault, and well, the blaming culture is the one where we point with the fingers at each person to say, okay, it's your fault if an incident happens. Why am I talking about it? My name is Nele. I'm a developer advocate for Fiberplane. I joined this company in January, and that also changed my relationship to Prometheus, because before it was a tool I've heard of, and since January, I almost daily open localhost 9090 to see what's going on in services and in the infrastructure, because Fiberplane builds tools to investigate and debug collaboratively infrastructure. There are notebooks where you can include data sources to collaboratively work on it. It's basically like Google Docs for SREs. And there is an open source framework called Autometrics, which I quite like because I don't have to write the PromQL queries. I can basically instrument my application functions, and then PromQL queries are written for me about latency, error rate, and the request rate. But actually, that was not the topic why I'm here. So the idea is we can create as many tools as we want. If an organization is still having a blameful culture, all those tools are kind of useless. So the problem when we have companies that are blaming each other, normally people don't like to speak up, and that's a problem when we want to handle incidents. And also organizations who do that focus more on the who is responsible than on the how to fix this. And I think almost everyone agrees that this is bad in the SRE space, but why do we still need to talk about it? Well, I think it's not as trivial to say, oh, we are not blaming anymore, we just use different language and we use different tools to do that. I think there are some more problems that we should be aware of, at least. And one of them is actually our own history. So how did we grow up, and what is our relation and our history when it comes to failure and error? And I don't know about you, but when I went to school, there was a basic rule: I had to write tests to get a grade. And the more errors I made, the worse the grade got. There was no reward afterwards for writing maybe a correction about those. And it was also not rewarded when you learn from them. But that's basically how I have a relation with my errors. The second thing is, or that's the first thing basically, the unlearning. So unlearning own patterns can be challenging. At least be aware what your own relation to errors and failure is. And the second thing is the organization, and I don't mean the organization saying, oh, we are implementing a blameless culture, now we don't blame each other anymore. I think there is a meta level to it. And that's basically the idea. How are, for example, managers leading? Are managers able to talk about failures openly in front of their teams? And also, are there rewards in an organization, for example, if you collaborate or if you talk about your failures? And then lastly, if those two things are working, then maybe we can talk about the tools that we use and that we implement, because then it makes sense to look at tools that enable different teams to look transparent on infrastructure, but also on services, and have opened the data for all the teams when it comes to debug and to investigate in the infrastructure. And that brings me to the end. I think if we want to have a blameless culture, it's first being aware of our own behaviors and of our own unlearning, then look at the organization and what the organization can do on a meta level to really enable blameless culture. And then lastly, maybe look at tools that help you to be transparent about your data when it comes to investigation. And then hopefully failure is no one's fault, but an opportunity to learn and grow. Thank you.
Thank you so much. Here. And I hope everybody's gonna like update their biography to like say they are working mostly on port 1990. All right. Yes. Perfect.
Thank you. Another pink hoodie. I am going to talk about autometrics, and specifically why metrics have a DX problem. So my name is Mies. I am the founder and CEO of a company called Fiberplane, where indeed we're doing collaborative notebooks for DevOps and SREs, not the topic of today. Question, how do you know if your users are having a particularly a good time? And of course, logs are the answer. And they kind of look like this. Not super great. But of course, the first thing that we do when we're writing code, print line statements, is sort of what we grew up with. The problems with logs is, of course, there's too much data to understand. They are expensive to store and to process. And like, why are we serializing everything to a ton of strings? Can we get more insightful data and more efficiently? And of course, we're at PromCon, so the answer is metrics. So the good things about metrics are you can actually measure stuff. That's great. They are order of magnitude cheaper than logs, and you get high-level insight. They have a high amount of signal, and of course, we can trigger alerts on these things when things are bad. They do have a few downsides. So you need to know what to count and how to do that, and that can be tricky. You need to instrument your code, which is a bit like writing unit tests, work to do the work. And of course, you need to know these queries and be able to formulate them, and it's a bit of an art. So we started thinking about how can we do developer-focused metrics that are trivial to add. You don't spend time about thinking what metrics to track. Explore a production environment from within your IDE, meet developers where they are. Function-based metrics. Functions are a fundamental building block of your code. Can we use those functions to actually create these metrics? Enter Autometrics. So it's an open source project. It's a micro framework for observability implemented in different programming languages such as Python, Rust, Golang, and a few others. And it's a fun and easy way to understand your code's performance in production. We use macros or decorators or metaprogramming to make it very ridiculously easy to add these metrics. So you can instrument any function with a decorator or a macro. We only track the most useful metrics, so request rate, error rate, the latency of any function. You can also create service level objectives, so define your availability actually inside your code. And it inserts links to Prometheus charts and writes PromQL for you so that you don't have to. This is kind of what it looks like inside Python. So you import the library, you define your objective, success rate, latency, and subsequently you decorate a function with the Autometrics decorator. And also in this particular case, you see the service level objective, which is attached. That's great. Here's a Rust example, and because there's also a VS Code extension, you can quickly go from like hovering over a function and instantly see the request rate and all of these metrics and instantly go to Prometheus. That's great, but of course, people want Grafana dashboards, so we created these as well. So you can see like the top 10 functions, see the behavior of your SLOs, all inside of Grafana. And we've also created a companion app called the Explorer, which has this module and function explorer that you can sort of have a look at, and that tracks all these metrics such as request rate, error rate, and latency. You can sort of see the query that's attached to that and instantly go from this function to VS Code, see the function that's misbehaving, and then subsequently go ahead and fix that. So what's next for Autometrics? Thinking about adding more metadata to the build info metric. So attach the Git repo, the branch name. We're already tracking the version information inside of that build info metric. Thinking about alerting workflows, instantly go from alert to misbehaving code. Obviously, OTLP push support's been a big topic today. Need to add that. And thinking about logging and how to attach, maybe using exemplars to attach logging context to a specific metric. And we've defined a roadmap getting to 1.0. So check out the repo autometrics the GitHub org autometrics dash dev, and feel free to chip in. Thank you.
All right, I'm going to do a lightning talk about the social event. If I can know, of all the people I can't. Okay, cool. So. Okay. First of all, thank you for all the great talks, for all the speakers. It was a really amazing day. I'm really looking forward to day 2 tomorrow. We have some equally amazing talks lined up. So yeah, maybe just another round of applause for all the speakers and for all the work they've put in. And yeah, the lightning talks are still available, slots for tomorrow. You can go to the registration again, and now you've seen what a lightning talk is. You can just sign up, even if you just spontaneously decide tomorrow that you want to do a lightning talk about your cool new side project that the world needs to see. Go and sign up. Yes, I think that's pretty much everything. We'll start with talks at 9:15 tomorrow, so there won't be an introduction talk. And I think everything else is on the schedule, etc. But now, finally, we are going to call it a day here, and then we're going to head over to Birgit. The social event, Jar is already there, setting everything up, so by the time the first people start arriving, it should be good, should be fun. I think you should take your badge, but I think we're also going to check your names on a piece of paper again, because we need to get like armbands and stuff. So be aware of that, but you should be able to get in, obviously. And then we'll have some food, drinks, and stuff, and obviously more socializing and fewer talks. That's it.